Sorry for the awkward pause here. I'm just going to let everyone get their seats. Was it? Oh. Super organic. Awesome. Okay. All right. Looks like everyone's getting settled. Thank you all for joining us. If you haven't met me, my name is Ethan Pitzer. I'm the project manager for Project Ilion. I'm sitting here with Gavin and Jalissa. We were formerly known as Project Curing Cancer, and so kind of as part of that journey, I'm going to hand it off to Gavin so that he can tell you a little bit about kind of our mission and our background.
All right, so we are fighting the adversary of cancer, and each year about 10 to $100 billion go into cancer research, and every single one of those years, 18 million new diagnoses happen for cancer, and 10 million deaths occur as people lose their fight to cancer. Our current treatments that we have end up being very invasive and very destructive and hurt people's bodies directly or their bank accounts, and it can cost up to tens to hundreds of thousands of dollars per year on average. We are dedicated to finding a solution that'll mitigate these problems and create a therapy that is less invasive and less costly. Now let me hand it back over to Ethan to talk about our team.
Yeah. So, the Ilion team is made up of the beautiful minds and faces you see on the screen in front of you. As I said before, my name is Ethan Pitzer, so I'm the project manager. And then we've got in the middle four, we have Ashley, Jalissa, Farhan, and Aveen. They run our lab design experimental design team. So anything that we do in the wet lab, the materials that we use, the designs for the actual lab experiments that we conduct, they control that. Gavin, that you just heard from, runs our literature team with Farhan. They allow us to effectively stand on the shoulders of giants as we do our research. We want to know what already exists, the failures of others, and the successes, so that we can effectively utilize the body of knowledge that already stands in this area. And then lastly, we have Daniel and James in this case. Sorry, I call him Jim. But Daniel does exposure opportunities for us, so that can mean conferences and just kind of ways to get our name out there, get us more well-connected. And then James tends to do our funding and grant work so that we can continue the longevity of the project, get into research, which Jalissa is going to tell you a little bit about.
Yeah, thank you, Ethan. So the most common types of cancers are breast, prostate, lung, and colorectal cancers, and this is a universal disease. It affects people of all ages, all nationalities, and over $200 billion were spent on cancer care in the U.S. alone in 2020. By 2040, the number of new cancer cases is expected to reach nearly 30 million, and over 15 million people are expected to die of cancer each year. And in a patient's final year of life, the cost of cancer treatment for that single patient averages over $100,000. So speaking of that, I'm going to pass it back to Ethan to talk about some of these current treatments.
Thank you. Yeah, so when you receive a cancer diagnosis and you have that kind of unfortunate day, there are really three main well-defined pathways, some of which you probably know. One of them is chemotherapy. It's usually ingested as a pill meant to target and kill any rapidly dividing cells in the body. Most of the time that means cancer. Sometimes it also means healthy cells. So while this is effective, it's also incredibly destructive to the rest of the body's ecosystem. After that, you get to radiation therapy, where the trend kind of continues. You're sending a very high energy beam of radiation into the body to either slow or stop the growth of cells, shrink the size of tumors. We like to compare this to burning down a forest to uproot a few bad trees. So you're very effective in destroying the tumor. At the same time, though, you do end up with a lot of collateral damage. And then the last option is surgery. This tends to work really well for small mass tumors. You can actually just go in and excise the tumor. The only risk that you run, though, is that you may leave behind cells that can then either migrate or mutate to develop further resistances. And through all of this research, we've developed a few main priorities that we want to keep in mind as we keep going. So, Gavin.
When we're looking at Project Ilion's priorities, we look at three key points: affordability, accessibility, and efficacy. With affordability, we're wanting to make sure that people don't have to lose their livelihoods to be able to save themselves and save their lives. With accessibility, we're wanting to make sure it can cover several different types of cancers, and so more people can be saved. And with efficacy, we're wanting to make sure that we are avoiding migration of cancer cells as well as protecting healthy tissue. Now let's bring it back over to look at our solution.
Yeah, thank you, Gavin. So our name Ilion came from the Greek word for Troy. We were really inspired by the Trojan horse story. I'm sure you guys all know it. So our goal is to invade tumors in the body and treat them before the cancer cells are able to realize that the treatment is ongoing and adapt or metastasize to other areas of the body. So this will lead to the best outcome for our patients, which Gavin's going to speak about.
All right, with our patients, we're wanting to make sure that we can tackle different types of cancers so we can help those 18 million new diagnoses per year. We're going to tackle breast cancer cell lines, to be able, since breast cancer covers more than 300,000 cases per year. Now let's look at our roadmap.
Yeah, thank you, Gavin. So, as Tyler spoke about earlier during the welcome address, this project started as just Project Cure Cancer, which is a really daunting task. So we started with a lot of ideation and background research so we could understand the problem, what are the current treatments available, and where do they fall short. And last fall, we attended the ARPA-H conference. There, we got to meet a lot of great professionals, both on the research side of cancer treatment and the funding side, which is very important as we continue our project. Since then, we've worked to secure more contacts, same thing, both on the research and funding side. Currently, we're developing our method. We're getting into a wet lab where we can start testing our method, trying to prove its efficacy. And lastly, we will perfect our delivery system so that we can deliver our drug to our patients. And lastly, Ethan's going to wrap us up.
Yeah. Okay, so the vision for impact. What do we want to do with Ilion? In an ideal world, we would be able to build kind of a new world in which receiving a cancer diagnosis is no longer something that's incredibly scary, that's incredibly frightening. The question is not how much profit can a company make. The question is not, can my body take the strain of going through this actual treatment process, or do I have enough money to save my own life? The only question that we want to have remain by the time we're done with our work is how long is it going to take for me to reclaim my life again? How long is it going to take for me to become me again? So, thank you for sharing your time with us. We're going to pass it off to some more research teams to share with you their work. Here's some of our references, but thank you very much.
Can we give it up again for the cancer group? That was awesome. If you guys have any questions for them, there is a link on the link tree if you go to our Instagram, and that's where you can post all questions for our projects. Next, we're going to have Project Pylon's Wings come on stage and join us and tell us about what they've been working on.
Oh, there's a clicker. I was wondering how they were moving the slides back and forth. All right. Howdy, everybody. Sweet. Thank you. Howdy, everybody. My name is Zach. I am currently the project lead for Project Pylon's Wings. There we go. A little bit about my background. I started here at Luminosity 3 years ago. I've worked on previous projects such as Charlotte, Axon, and now I'm very excited to get to continue that legacy working on space solutions. So now I'm going to hand it over to Connor to introduce himself.
Hi guys, I'm Connor. I'm a junior here, and I was here last year through the Vanderbilt Scholars. This is my second year now, and I'm the mechanical lead for the project.
Awesome, thanks so much. And we go down, yeah. A little bit about the project itself. It actually started last year as a project known as Space to Solve Climate Change. The Interplanetary Initiative came to Luminosity to kind of ideate ways that we can use space to help solve climate change, which is a very, very open-ended problem. And we were trying to go through the process of figuring out different engineering solutions on how we could do that. One of the techniques that came up was power beaming, and how we could potentially utilize resources in space, such as solar panels or other power generation systems, and beam it back down to Earth in order to help address the gap for power generation here on Earth. For those of you who don't know, the energy demand for this year alone is expected to be an extra 2,500 terawatts, which is a huge amount of power. I did some of the calculations on the Palo Verde nuclear plant, and we'd need the equivalent of about 100 of them to make up the shortfall for the amount of power that we need for this year alone. So that raises the question of what are some other innovative ways that we could generate this power to kind of address that shortfall, and one of them is power beaming, like I said before. So next up, we're going to talk a little bit about the actual solution that we've designed.
So we designed a way for transmitting power. It's called power beaming using an intelligent metasurface. And what we plan on doing is basically, say I'm a solar panel, and I'm going to bring it to my antenna, and I'm going to radiate energy normally to like a receiving antenna. So boom, boom. And he receives it. But that's kind of difficult to do, especially if, say, he's on the other side of the Earth, or he's a space shuttle and I can't see him directly, or sometimes there's wires in between, but like we can't really do that. So what we can do is we can use an intelligent metasurface, which is basically a patch antenna with a bunch of pins on it, and by varying the number of pins, you can vary the frequency and the direction that you beam. So say there's another one, I get some power, and I'm the intelligent metasurface. I'm then going to beam it towards Zach, and Zach's then going to receive it. So the end goal is to kind of have power beaming in space, being able to transmit power from, you guys are familiar with like what a Dyson sphere is? Something like that. Basically, it's like the idea that you can like surround the entire sun with solar panels to harness all the sun's energy. And the idea, like if you're doing that, you can't really just put some wires. So our entire project and our mission is to put this in space and prove that you can actually do this in space, because no one's done it. So we want to do the first.
Yeah, do you want to touch up on the partnership with Interplanetary Lab and what we're doing with that?
Oh yeah, the amazing people at the Interplanetary Lab are creating kind of bus, and we're going to put our payload into their bus. It's called SquidSat. It looks adorable. It's basically a box. It's called a 3U. So there's different units, and we're going to take up 1U, and there's another payload on there as well. And there are solar panels that line the 4 edges of the box, and then when we get up there, it then deploys the solar panels. It looks like a squid, kind of like from Minecraft. But they have done, I think, 2 previous CubeSats, so they have a lot of experience, and they have a lot of they have some great testing facilities that we get to use, like a Vibe testing stand and thermal vac chamber, and just super smart people. So super fun collab with them.
Awesome. And then up next is a little about the design of it.
So looking at the components, we have our wonderful rendering of the sort of idea that the concept idea. Basically, imagine you have a spring or a tape measure, and that tape is then going to extend with an antenna on the end. We've developed that it's going to have 2 antennas transmitting and a receiving antenna. So imagine my hand is both the receiving and the sending, so there's like 2 separate ones, and we're going to power beam towards my chest, and then we're going to shoot it back. And then we're going to go into with the reconfigurable metasurface itself. Right now we're working with Dr. Trichonopoulos, if I pronounce that right. I call him Dr. Antenna because he's very smart about antennas. He has about, currently with the one we're working with right now, has about 256 bits of like control or pins. And that gives us a wide range of frequencies to operate at, as well as a wide ability to power beam. And SAR1 is actually our electrical lead, and he's spearheading that design with Bilal. He's doing an amazing job. And then the flight software is being led by Ashton, I'm pretty sure, right? Or
yeah,
he's the code lead. And they're using F prime, which is what NASA uses. So we're getting students experience with NASA level software. We're designing things for NASA level requirements. We're looking at those requirements. We're designing things to the highest level of perfection.
Now a little bit about what the next steps for the project actually are. So like Connor mentioned, we will be launching aboard a CubeSat in about 2027. So we're going through the steps of designing our initial prototype to perform our preliminary design review, which is going to be essentially pitching our research and kind of the engineering behind it to a bunch of industry experts who are going to grill us on why we think our project is actually going to work, and we have to prove that, yes, it will work. The next steps from there are going to be actually creating the prototype, going through all of the different verification and validation steps. So like Connor said, we have to do thermal vacuum chamber testing, where we're essentially going to be simulating its environment in space, dropping the temperature down really low, putting it under a vacuum, seeing if any of the different mechanical components fail, bringing the temperature up to simulate it now in the sun, heating it back up, and then repeating that process probably about 50 or so times. But this way, we have a product that we know is going to work, and we can deliver it to NASA and not have it fail in space, because unfortunately, we can't just take like a wrench up in space and fix it real quick. It has to work first time, no matter what. Some other things that we're doing are developing kind of a path to commercialization. One of the ideas that we have is obviously beaming power from space back down to Earth, but we also had the idea of kind of creating a distributed power grid in space, which would be pretty cool. Haven't heard of very many other companies that are trying to do that. And this would allow us to not have to use heritage technology like power lines up in space, and instead, we could just beam power back and forth between different satellites. And that will also reduce the amount of cost it takes to launch, because now they don't need as much power generation circuitry in them. Instead, they can just utilize a power grid system up in space. We're also trying to apply for some external grants, such as the DARPA and Viasat competition, so that we can help bring this product to fruition. Next up, I just want to give a huge shout out to all of these amazing people on this list that are making this project possible. I think this one really exemplifies what it means to be in the Luminosity Lab, because it is a very interdisciplinary project. We have mechanical engineers, electrical engineers, software engineers, verification engineers, systems engineers, pretty much have a use for every single type of engineer out there to make this a complete product that we're confident is going to work up in space. And so with that, thank you so much for listening to our presentation.
Thank you. Good.
Yeah.
What was the most challenging part of this project so far?
Want to go first?
Sure. The most challenging part of the project so far was, I think, getting past the kind of initial ideation phase of what the project was going to be. We started out with that very broad problem of space to solve climate change, defining out the requirements from there, but then we have to work under constraints that we're not normally familiar with up in space. So very basic things like gravity don't really exist up there, so instead we have to model the forces that are going to be on the CubeSat in a different way, even down to things like gases that are contained within the metal. We have to first outgas them, which we didn't know about. So going through the process of figuring out how to handle space was probably the most difficult so far.
Probably figuring out what requirements we need to get, because it's not like, oh, you need to hit this, this, and this, and this. There's a lot of variables, there's a lot of factors, especially depending on who the launch service provider is, basically who's sending us up there, what vehicle are we taking, what dispenser are we going in, and basically just trying to navigate a lot of papers. Too many.
Sweet, thank you.
Awesome. Now we have Project KIP. Why don't you guys make your way up here? This is a really cool project. While they're taking their time to set up, do we have any questions for Project Ilion? Yeah? Why don't you guys come up here really quickly? Yeah, take your time to set up.
Yeah. How do you guys plan on achieving your goal? Like, do you guys have like a specific idea that you're gonna go with?
Yeah. Do you want to talk about it?
Sure. So, can I get into details here because it's internal? Okay,
Yeah.
just wanted to make sure, NDA wise. Okay. So currently we are focusing on the glutamine molecule, which is a really essential amino acid for cells that a lot of cancer cell lines lose the ability to produce themselves. So our goal is to alter the glutamine molecule in a way that it can still bind to cell receptors on the outside of the cell membrane. So the cell will take it in and think, okay, yay, I have glutamine, but it won't be actually glutamine. So then when the cell tries to use it, it won't work. So it'll essentially starve the cancer cells because it won't have an essential amino acid. Anything you want to add?
Yeah, the only thing I would add is probably a little bit of the why. Cancer has a really unique ability to evade whatever strategy you tend to use. So if you just full-on cut off the glutamine supply and the cancer can recognize that it's not receiving glutamine, it will either rely on a new energy source or it'll start consuming your surrounding healthy cells. So we need to find a way to start to treat it so that it doesn't have the likelihood of migrating to somewhere else or starting to develop new pathways and resistances to where you didn't actually make an effect in the first place. Any other questions? Yeah.
How do you differentiate between a regular cell wanting glutamine and a cancer cell? Is it different cell receptor size or something?
Sure. So that's as part of our roadmap. That was the perfect the delivery system. So part of what we're doing is we're looking into now computational protein design. It's a new field. There are now AI integrated softwares that allow you to customize certain proteins that exist in the body. We want to figure out a way to biomark specific cancer cells as opposed to others, differentiate them, and then make an effective delivery system so that we can essentially drop off what we call the ileon particle, the modified glutamine, to the cancer cell locally so that you're not then administering it to all of the surrounding cells. Anyone else? Are you guys ready? It's for you.
Cool. Okay. Hello, everybody. My name is Charlotte. I am a first-year Vanderplas Scholar. I am studying engineering science with a concentration in business, and I am the project lead for Project KIP. And this is Ashton, and he is in computer science and has been our embedded systems developer. So just to kind of give a little bit of an introduction, KIP was a previously completed lab project way back in 2017. Started with Myra, Make Your Robot Awesome. The previous iteration is actually sitting over there. And it was a robotics education platform for students to learn the basics of robotics. Since it was back in 2017, there weren't a lot of platforms like there are today. But kind of coming back into today, KIP has been reimagined with neurodivergent individuals in mind. So it has AI integration and a pretty simple building process for those individuals to understand. Along with that, there's not a lot of STEM programs out there designed for neurodivergent individuals. They are just kind of the regular programs taken down to the level of understanding that special education programs would need. So that's what we designed this for. So starting with our team, all of these people are great and very smart. I do want to mention that a lot of us are Vanderplas Scholars and or our first time in the lab. So this has been a learning opportunity for a lot of us, especially for me leading a project like this. So we have Ashton working on those embedded systems, Alex working on our app and AI integration, Ashley's doing our website, Bilal has our PCB design, Quinn has helped with our logo, Ronit's done our updated CAD and mechanical systems, Taylor's been great with research, and then Zach has also been helping with those embedded systems and just being kind of a lead for us as well. So with obviously, like I've been saying, there's not a lot of programs out there for neurodivergent and special education programs for robotics education and learning the basics of robotics. So actually, there's a lot that comes with benefits with STEM, especially for neurodivergent individuals, as they can break down things. It helps with problem solving, as well as making new friends and kind of reframing their thinking into one that's better and going through the design process. So our overall vision is to create a world where every learner can learn robotics in a simple and fun way, and that's not daunting and uses 21st century technology to their advantage. And then our mission just for this past year has been to reimagine KIP, update it, bring it back up to current hardware and all that stuff, as well as include that AI integration.
Cool. So how we went about achieving our goals is kind of the three major areas. So we wanted to update the hardware of KIP first. The previous iteration or generation had a lot more components that were working together. The components were harder to use. So we decided to update to a Raspberry Pi Pico microcontroller that has Bluetooth capability and Wi-Fi so that we could control KIP remotely with just one board. We also updated to continuous motors versus a stepper motor design, which is a lot easier to program and work with. We also redesigned the PCB to be a bit more compact. This is all thanks to Bilal. And then we also added Bluetooth control. The previous generation used Wi-Fi to control it, and we decided that Bluetooth was a lot more of an accessible option. The other area that we started developing is an app, which will be the container for the AI engagement, the chatbot, the curriculum, and then as well as the controller. So currently we're using a Steam Deck to control KIP. This is a very temporary solution as the app is still in development, but the idea is obviously this Steam Deck is very expensive and therefore would make KIP very much not accessible to most people. So by putting the controller in the app, we hit that accessibility point. Yeah, and then Charlotte's going to talk about the AI integration.
Yeah, so our AI integration is through our chatbot, where it will provide personalized building instructions based on the student that uses it. So this can kind of be clumping steps together or breaking them down even further to an understanding that the student can use. And then as well as that, we have wanted to implement text-to-command code assistance. So that is the student can enter into the chatbot, turn right, and KIP would turn right. Same thing with turn left, turn back, or move backwards, all of that. And then at the end, they would get a log of that code. So they have a starting place of what code looks like and exactly how KIP moved the way it did. Along with that, the chatbot has an overall understanding that it's talking to neurodivergent students. So it understands frustration, it kind of helps reframe their thinking, calm them down, and again, break it down into a way that is more understandable for them.
Cool, so a little on the timeline of this project. We started ideating back in August, and we're doing a lot of exploring and initial development throughout the fall semester. We really didn't get something like moving until early in this semester, and now we're starting to work on text-to-command execution, so being able to chat with the chatbot and say, hey, can you turn right possibly? And the robot will turn right. That's something we're working on at the moment. And then for the future, we're hoping to maybe redesign KIP a little bit. This is very much a port from the previous generation, and it would be nice to make that a little bit more updated. We also want to refine the chatbot and incorporate that instruction for building and the curriculum for teachers. So a little bit for our demo. I think, is that video going to play? Okay. Yeah, what you see on the screen is just the outline of our app. It's what Ashley's been working on. No worries. Well, and then we can also show you that KIP is actually up and moving today. So, we can, oh no, did this disconnect? Hold on.
Wow, isn't robotics great? This is a perfect example of stuff that can happen with this. I'll go a little bit into. Well, perfect. While he's doing that, I'll go a little bit into the demo. Unfortunately, sorry that the video isn't playing, but Ashley has been working on this website. It looks great. Along with that, we do have the AI assistant in there. Come find us tomorrow or when you have time, and I can show you the video of the demo. But in that, it basically says what I said about the text-to-code assistance, as well as knows that it's KIP and that it's a robotics learning platform, and that it's dealing with children or neurodivergent individuals. So it has that overall caring theme to it. So yeah. So going into some of our competition, there wasn't as much competition when KIP was first made. Like I said, because it was a little bit ago, but now there are quite a few competitors. So one of our main ones is MakeBlock. They have something called the MBot, and that is a robotics learning platform. There's some AI incorporation for coding assistance just to get started. And those ones are pretty cheap, but I know personally, my mom is a teacher. She has used these and did not like them at all. It was not user-friendly, especially for teachers, and very unrealistic for high student-teacher ratios, because she's just one teacher. She had 20 students. All of them needed help. She couldn't be everywhere. Same thing goes for Easy Robot. That one is 4th grade through university, so there's a lot more applications with it, but it's very, very, very expensive, so in the thousands of dollars. So again, that's not really realistic, especially for special education programs that don't get a lot of funding. Every Kid Gets a Robot, that's what that acronym is. That one is our biggest competitor from a price standpoint. They're made from recycled plastic, so it's less than $20, and it's for underserved youth, but being that it is under $20, it's pretty basic, so there's not a lot of functionality other than just driving. And then QT Robot, that one is the AI-powered social emotional learning and designed specifically for autism spectrum disorder. So that one is similar, and we've been taking some inspiration from them on how they communicate with the kids and all of that. So, and then going into our services, so just how we're better than the competition. We're simple, so we have obviously everything is 3D printed, having those building instructions be personalized to the student. Affordability, low cost is a big priority for us, especially, like I said, those special education programs haven't been funded. So this iteration costs under $50 is what we're saying to make. What we've been looking at is under $100, so hopefully we can keep it in that. And then also accessibility. So with the incorporation of AI, any student is allowed to use it or can use it, and it'll kind of meet them where they're at and then expand their learning.
Okay, so for some of the next steps in terms of the robot companion, currently we have a Bluetooth protocol written between the Steam Deck and the KIP companion, but obviously we want this to be an app to hit our accessibility standpoint like I was talking about earlier, so we're going to integrate the Bluetooth protocol that we see here into an app that can be used on any device. We want to implement AI interfacing with the chassis, like I was talking about with the, hey, turn right, and then the chassis can turn right, and eventually those commands could evolve to become more and more sophisticated, hopefully, and more intricate. We are also going to work on finalizing, redesigning the KIP design, adding personality via some eyes, maybe an arm, emotes with the wheels, and then also just furthering the control of the drivetrain. It's currently okay. It looks pretty nice, but it could be a lot better. So yeah, and then Charlotte will talk about the education.
Yeah, so just is really tackling the education part of it, how to implement it into classrooms or other special education programs. And so we want to really make it accessible, make sure that there's visual instructions that go along with the personalized ones from the AI, as well as finding the correct way to propose curriculum and develop a summer camp for those schools that maybe can't implement it as something in their school, but they would like, obviously, their students to participate in it. So, yeah, so that's all we have. Can I open it to questions? Okay. Does anybody have any questions? Okay, great. Yeah, so that's something that I've been thinking of. I think it'll probably be an upfront cost. There's a lot. Our competitors have those subscriptions, and those subscriptions are really where it gets you. Like, they're really expensive. So I would like to keep it as an upfront cost, and then have almost everything else be free, and it kind of be a sponsored thing. So we'll see where that goes, but hopefully upfront costs. Yeah. So those I just kind of went along and saw what each thing had, and if they had AI integration, if they were inexpensive, if they were across a large age range. So the Maker Block, that one had the highest percentage because it had that AI integration. It was cheap, and it had it's a pretty simplistic design where everything is, it's pretty easy to tell where, you know, what goes together. So that one being the most similar, and then the one on the lower end being the QT robot, just having that AI integration. So that's, you know, really just one of our pillars. So, yeah. So right now, so like I've said, my mom is a teacher. So at a Title I K through 8 charter school with a lot of students who have learning, special learning needs. So she's been looking into trying to get it implemented, at least one, to see the interest of her students, as well as ASU Prep. We're looking into seeing if they're interested in using one and seeing what their students think. From there, honestly, like word of mouth, and then hopefully going for Arizona schools and just kind of going from there outside. Again, it's been kind of hard to think about it as a mass production just because we're focusing on one thing right now and there's a lot of moving parts. So, but yeah, starting smaller. Yeah. Mhm. Mhm. Yeah, that is definitely something that I had been thinking about, having a sponsor just kind of be the main, you know, getting us out there and off the ground. Like you said, having those other features students or individuals can pay for as they get older. We were actually just talking about that. Adding an arm would be one of those things, possibly adding speakers to have it talk to you, because it is that companion as well once it's built. But yes, definitely looking into sponsorships with that. Just kind of seeing what company would want it, if it would be more of a tech company or an education. So, yeah. Yes, I did not know that he would be here. So that will definitely be something that we do. I was mainly thinking Paradise Valley Unified School District. That one, kind of starting there at the district level, and then going statewide, just to start smaller, see the what level of students benefit the most, just because in that district there are charter schools and K through 8 and high schools and special education. So definitely looking at the district level first and then going statewide, but definitely what we're looking into. Yeah, thank you. Thank you for that discussion. Look into it. Okay, anything else? Thank you, guys.
Awesome. I think next up we have Munch. This is the first time I've actually seen the fungi, so this is like a true science experiment. Yeah. You don't want to hold it the whole time? No, you're good. All right, without further ado, let's get a round of applause for the mushroom.
Hello, my name is James, or Jim Perry, whichever, and I am the project lead for Munch, and there's supposedly a clicker up here somewhere. Ah, excellent, thank you. Okay, yes, I'm the project lead for Munch, which stands for Mycological Unit of Neutralization, or Mycological Unit for Neutralization of Contaminants and Hydrocarbons, which essentially means a self-contained unit to degrade plastics, regardless of contaminants, especially biological contaminants. Basically, a compost bin that you can toss your plastics into, and it'll degrade it into biologically available molecules. So, why this? As we all know, plastic waste and use increases and continues to increase year after year, with only about 9% of all plastics being recycled in any given year. A lot of plastics don't get recycled because they're impure, they're contaminated, especially with things like food waste, or just water is enough to contaminate things that they can't be recycled. So the goal was to try to find something that doesn't care about those contaminants or doesn't care about the purity and will just handle it on its own. Additionally, as we've all heard more and more frequently, microplastics are a bigger and bigger problem in our food, our water, our soil, our clothes, even in our own bodies. So trying to find something that can attack things on a microscopic level is even better. So when we went to decide this contraption, we had two major things to consider. First, the box, and then the mushrooms. In terms of the box, we isolated a lot of important key variables to keep constant and keep consistent, such as temperature, pH, O2 and CO2 levels, and just general substrate consistency, whether we're growing them on a solid substrate, liquid, etc., etc. And then what do we do for the fungus? In doing the literature review for this, we found a lot of really good and really effective fungi that are also good at attacking humans as well as plastic. The number one plastic-eating fungus is Aspergillus niger, which when humans are exposed to it, we develop aspergillosis, which is a respiratory infection. So we have to balance out our needs with the dangers of specific fungi. In trying to find an answer for this, we went and talked to Dr. Catherine Gehrig, a mycologist up at NAU, who specializes in the relationship between mushrooms and trees up in the Flagstaff area. And she recommended to us two different wood rot fungi. This here is our Pleurotus ostriatus, or oyster mushrooms. And then back in Sun Devil, currently still hanging out, I didn't want to bring them all with me today, are our turkey tail mushrooms, or Trametes versicolor. These mushrooms are both really, really good at breaking down lignin and cellulose in plants, which are long, complicated molecules that are somewhat similar to hydrocarbons in that they don't have one specific shape that they always take, and part of their strength is that they form these complex overlapping building blocks. So these mushrooms that have the capacity to degrade those complex molecules can very easily translate that over into breaking down hydrocarbons, or more easily than other organisms. So we took these and we grew these grow kits. As you can see, they're doing rather well. We're very proud. We grew these grow kits and then took samples from them to grow in our speed plates. Up here on the very bottom most level is just plain agar containing 10% sugar. So it's seeded at one end. We will measure how far that grows, and that'll be our control. In the two rows above is an increasing plastic concentration, starting at 0, then moving to 10, 40, 60, and 80, 80 being our max percentage of plastic by volume, to see how well these fungus can grow through the plastic and how well adapted they are to it. These are our stages of incubators, where we've come from, where we are now, starting with a essentially trash bag taped up to a shelf in my room, moving up to our cabinet currently sitting in Sun Devil Hall that is Luminosity Yellow. Thank you, team, for deciding that. And then where do we go from here? These plates were seeded last week. I told them that I really wanted results by Expo, but they didn't get the message, so they're still hanging out. But we will continue to monitor those plates, seeing how well they grow and what we can do to maybe encourage that growth. And then working on moving forward with the box prototype and designing something that we can hopefully implement into our use. So thank you. And then there is the team. Then do I have time for questions? Okay. Any questions? Yes. The plastic, yes. We first made the agar solution, brought that to a boil, and then added the appropriate amount of plastic to that, mixed it in, and then poured those into the plates. Did you like chop it up and wash it, or did you just scrub it with plastic bottles? We were able to source the plastic that we used. It's polyethylene, it's polyurethane plastic. We were able to source as a polyfill just from Amazon, and we were able to buy it in bulk. And we sanitized it through the boiling of the medium. Yeah. Other questions? All right. Yeah.
You guys have any plans on how you're going to build the box? Do you have any people that are spearheading the design of the box, like heating temperature control, humidity control? How do you guys plan on doing that? Like, do you plan on this being used in every home as kind of a thing like that, or what's the scale?
Ideally, yes. Household use is our goal. Like just having everyday people getting rid of their plastic waste. That will probably be the last area of advancement that we make, just because it's easier to maintain boxes like this if you have some sort of specialized training. So likely this will be something that's implemented either at the corporate or the community level as a way for factories to get rid of their plastic waste there on site, or for recycling plants to get rid of contaminated waste there instead of having to send it somewhere else. So long-term goal, yes, having it at a household level. More likely first steps will be corporate and community. Yes. Good question. The good thing about fungus is that it grows to fit the space that it's in. So theoretically, the box could be however big it needs to. The main factors that affect how big the box will end up being is how fast the fungus can degrade plastic. Currently, an average like a garbage can would take about 4 to 6 months to fully degrade, which is the reason why we don't have mushrooms degrading our plastic already. So we're trying to find ways to speed that process up and make that box smaller so that we don't need to have as much fungus working all the time, and that we can cycle through it and get it ready quicker. But, yeah. So the fungus doesn't go anywhere. The fungus just stays in there, similar to if you see mold growing on bread, the bread will get eaten, but the mold stays. Mold is a type of fungus. So the fungus will stay there, but it will eat through the substrate that it's on, and it'll turn that into largely just water and CO2. That's also why your bread will like kind of dissolve into a puddle. It's because it's producing water from breaking down the sugars that are already in there. So our goal is to take these like long chain hydrocarbons and break them down into CO2 and water so that the fungus won't go anywhere, but the plastic will largely just go into the air. Does that answer your question? Okay. All right. Alrighty, thank you.
Thank you. Give it up for Jim. This is insane, and the whole Munch team. You guys did a phenomenal job. As someone with a sustainability background, I am biased towards really cool sustainability projects. Of course, I love all of your projects, but that's insane. And I'm also a plastic person, so that's pretty cool. Next, we have Care Ascension. So let's make our way up. And I think we'll leave this on here because you guys need oh, got it. Cool. Should we move this down?
Oh,
Yeah, let's move it down.
yeah.
Can I have someone over here? I can't carry it.
Thank you. It's down, right? Yeah. Okay, hello everyone. How are you guys doing? I know it's almost lunch, so it's okay if you're not doing good. But my name is Ashley Maddox, this is Maria, and this is Jocelyn. And before I share a talk about Care Ascension, I want you guys to meet Sheila. Well, obviously she couldn't be here today, but she wanted me to tell you that she is a mother of 3. She unfortunately recently lost her job, recently lost her home, and is currently dealing with an infection. She had to go to the hospital because she doesn't have proper insurance, wasn't able to get treated. Goes to a shelter beds are full. And now her family, as well as herself, are unsheltered. Her infection is still infected, and she has to find a way to find housing for her family. This is a failure to the healthcare system, and it's a failure due to healthcare delivery. And this is a failure that Care Ascension aims to fix. So Sheila's situation is actually not unique. This is something that happens to a lot of people very often. In fact, it is currently happening to over 700,000 individuals. And when I was here last year pitching for Care Ascension, this number was only 623,000. So there has been an increase in homelessness. This is a result of lack of coordination and lack of resources. And this is because there is no connection between shelters and hospital providers. And this gap leads to worsening healthcare as well as higher hospital readmissions. Now I'm gonna kick it off to Jocelyn to talk about the stats.
Thank you, Ashley. So we do have some statistics here regarding the homelessness here in Arizona. As of January 2023, we did have over 14,000 individuals who did suffer homelessness. This was a 29% increase from 2020. Over the past 5 years, this increase has been 73%. As we can see in this graph right here, we can see a pattern. It just continues to increase, and we just predict that in the next few years, it's just going to drastically increase, and that's obviously a big issue here. I'm going to be giving it back to Mario, and she's going to discuss with you some of our objectives.
Thank you, Jocelyn. Care Ascension has a few objectives, all which help our mission to bridge the gap between homelessness and healthcare. We do these by building key partnerships with places such as Maricopa County Health Department and the Real ID Project, as well as centralizing essential resources by building networks to connect people with shelters, food pantries, clinics, and donations. Finally, we want to enable real-time updates to help shelters create a system that updates availability in real time and showing them beds, tracking systems, and everything that helps them. We're aiming to do this by a 3-phase solution. First, our shelter tracking system, which I just talked about, that allows them to track beds in real time, enabling all shelters to communicate and coordinate efficiently. We also want to integrate these into shelters themselves with our digital kiosks, which we showed over there. And finally, integrating this within hospitals by establishing hospital-shelter partnerships to help with discharge care. I'm going to be passing this off to Ashley to show us our user interface.
So as Maria mentioned, we want to create a shelter tracking system. This is something that actually isn't in the market at all. There is no universal way to track shelter availability. So this is what we created. This was just the staff user interface. So as you can see, staffs are able to check bed availability as well as the room management system. And then this is what the check-in and check-out feature would look like when a client does check in. And I'm going to kind of demonstrate a walkthrough of how a staff would go about checking in their patient. I guess my video isn't working either. But here, let's see. Let's see if this will work.
If it doesn't work, then that's no problem. I can just talk about it. So as you can see over here, this is the staff login. So what will happen is staff will put in their information. We don't want to be able to provide anything that's confidential because there is patient information. So once the staff is able to log in, they were able to see the available beds for each room. So this is, for example, Hope Haven, and this is a medical recovery bed. This bed has 9 rooms, and as well as rooms that people can check in and check out. On the right side, you can see the availability. There are different colors. Some means maintenance, the other ones probably mean it has to get checked out or it is available, and that is how the staff will be able to check in clients. And then on this slide, you can kind of see the QR code. What many people don't know is that on the Human Services campus, everyone is given an ID. That ID is what we're going to use to implement the tracking system, and that's how people are going to check in and check out. I'm going to see if the video works again. If not, then we'll just keep going. Oh, yes, perfect. Okay, oh, actually, no, that's not the video. Okay, perfect. Thank you so much. So, like I mentioned, this is the home screen. This is what someone will see before they sign in. Once they do sign in, they just log in with whatever login code that they have, and then they will press login. This is kind of where the real action happens. You see the announcements, you can see their shifts, you can see where they're logging, but we want to check the dashboard. This real-time dashboard is what we are going to use to check availability. So as you see, we have bed availability, we have the shelter overview. This tracks all the beds statewide, but today we're going to talk about bed availability. I did kind of talk about this already, but like I mentioned, this is Hope Haven, this is a medical recovery room. This is what people will see when they do want to track their beds. Like I mentioned, this has 9 beds as well as an overall timesheet that people can check to see the availability for that room for that day. And this is kind of like what the schedule looks like. From beds B1 to B9, and like I mentioned, there are different categories and colors for each availability. And also each bed has their own individual availability, so if someone wants to check it out, you can see who checked it out, as well as you can see like if there's maintenance, why there's maintenance, who issued the maintenance, things like that. And you can also check to see how someone does go about checking in. Like I mentioned, with a QR code, this is what it will look like. It has their patient information, their name, their profile, and the bed that they want to check in. Once they check in, you are able to see the schedule change from, I think, gray to green to show that it is being in use, and that is what the state will be able to use to track the bed availability. And then if someone checks out, same process, using the QR code, and then the patient information will come open again, and then they'll be able to check out as normal. But this is kind of to help alleviate the process of checking in beds, as well as the process of having availability of a bed. And then also, we don't want anyone just checking in bed or checking out. So if you're not using the QR code that you use to check in, you'll be met with an invalid code. But yeah, this is what our interface looks like from the staff's point of view. Okay, and then the next slide, I don't know if I have access from here. Okay, now I'm going to give it to Jocelyn to talk about our timeline.
So this is Care Ascension's timeline. First off, we have project development. We do want to have a finalized kiosk product as well as the interface, which we've kind of been currently working on. And we do want to proceed with interviews and user testing. We want to get feedback from healthcare providers as well as shelters. We want to continue to build partnerships and to start integrating that kiosk that we just showed you guys, the whole interface thing. We want to start integrating it into shelters and have people actually use it. This would obviously lead to our first viable product being launched, and we do want Care Ascension to reach nationwide expansion. That would be the end goal. So this is Care Ascension. Some of these individuals are sitting down right here, like in the second row. So we are very grateful for everyone who dedicated a lot of their time to Care Ascension and the mission. So yeah, we're just very grateful for everyone who made it here. I'm going to give it to Mario. She's going to be ending this lovely presentation.
Yeah, again, a big thank you to all of our team members. We put a lot of time and work into Care Ascension, but ultimately we are about the people. We aim to help all the in-house people gain access to all the resources available to them, as well as ease the stress and workload on hospitals and shelters within Arizona and hopefully nationwide.
Thank you. Oh, do we have any questions?
Who has the QR code? Is it the person seeking housing that has the QR code? How do they have it? Is it like on an ID card or how is that available?
Yeah, no, that's a really good question. So there are people that reside in like the Human Services campus, and think about like the zone got disbanded. So if you were in that area in a shelter, they actually provide you like the shelter's own ID. The only thing we would do is put a QR code on the back of that ID, so people can just go in and go out. So there's already like an ID implemented. We would just put the QR code on the back.
And that's in collaboration with the Real ID project, because most unhoused people don't actually have IDs within Arizona, like a very large number we found out. And so they're working to provide them IDs, that way they can find jobs, do all this. So we want to work with those IDs and collaborate with those QR codes.
And then I guess to also further emphasize that it's a three-phase solution. So the first solution is just really trying to create the shelter tracking network, and from there being able to implement that into an actual shelter using a digital kiosk. And then from there, the third phase and ultimate phase is create a connection between hospitals and shelters. Oftentimes when you are discharged but you're unhoused, you don't actually have post-care recovery or a place to stay and actually recover. So trying to reserve beds within a shelter, the hospitals can transmit their patients into the shelter so they actually can recover properly. Really advancing healthcare delivery. Any other questions? No? Okay, perfect. Thank you so much.
Awesome job. That was a phenomenal presentation. With that, we are actually going to break. Lunch will be ready in about 15 minutes. So you guys are welcome to go use the bathroom, chat, look at the projects, network, and then we'll get started with lunch in a bit. Thanks, guys.
Oh, I love that. That's a good one. That's a good one.
Let's see. Who's our first? Where's Nadia? Oh, there you are. Okay. Hi. Awesome. Cool. All right, so we're gonna start with Project Pepper. Yeah? Yeah. We'll cue up your presentation. Yes. Awesome. Yes. That's it. Yeah. Down? Down. Yep. Down and forward. I know. Jones, your jumping jacks. Shake off the lunch.
Okay. Where are our slides?
We have a slide for that.
We'll get to it. Okay, there we go. Okay, really quickly, can we give a round of applause to Jasmine for all the hard work she's been doing with the expo and the lab? Okay, so I'm here to present to you Project Pepper. Now, PEPPER stands for Project Engineered Plant Production for Expedition Research. This has been a 2-year-long research project where last year we focused more on building a physical prototype, and this year we focused more on doing research and kind of expanding on our previous design. So quick introductions. I'm Nabil Alum.
Hi, I'm Julissa Brunk.
Hi, I'm Diana Encinas. And I will be telling you guys about the problem that we focused on for Project Pepper. So currently, nearly all food on the ISS is packaged in freeze-dried packages, and it is very high cost to bring food to the ISS, which limits the availability of food, and it is highly processed and unappetizing. Here are some statistics from NASA. 10 to 15% body mass reported lost by ISS crew members, 2% bone mass lost per month an astronaut is in space, and 25 to 30% less food consumption than before missions. These are obviously life-threatening concerns, so it is something that needs to be addressed. Our previous solution was a hydroponic system designed to grow fruits and vegetables on the ISS with a pump system that we used to control the movement of the air and water to get to the roots. And in a traditional hydroponic system, the air would flow upwards to the roots to provide the oxygen. But this isn't the case because it is a microgravity environment, so that's why we decided to use a pump system instead. This, however, didn't work because the pump system complicated the design. It increased its cost by adding weight to the prototype, and it increased risk of failure. It added unnecessary electronics and additional tubing, which we ultimately decided to remove completely so that the plant roots had more room to grow. And our team was unsure if the air bubble would also collect near the roots. Oh, it doesn't work. Okay. Well, this is a test ran by NASA where they put air in an air bubble and it created a ripple effect. You can go to the next one. And then this is a second test they ran where they added water into the water bubble and it created a bubble within the bubble. And this led to many questions.
Okay, thank you, Diana. So, did you want to talk more about the research?
This added more questions. Will our design cause additional air pockets to form? And will the roots cause these air pockets to burst or collect as it was shown in the video? And can we experiment this in space? Yes, we can. There was a CubeSat option that was explored, but later we did not pursue due to funding. And now I will pass it on to Nabia to talk more about her research.
Okay, thank you, Diana. So as she mentioned, one of the bigger problems that we were facing is that we didn't have a good understanding of how air bubbles worked in space, and we quickly realized that we were running into the fuel tank problem, which I know this video isn't playing. But essentially what's happening is that the air bubbles would get trapped in the tank and then cause the engine to burst in and out, which is clearly not something you would want. NASA has already solved this issue, and they've used capillary action and surface tension to kind of push the fuel towards the end and give the engine more of a constant flow.
So kind of inspired by their solution, we thought, how can we implement this into our project? How can we also use capillary action and surface tension to move the water where we want it to go, like near the roots? So we decided to use a porous material to kind of mimic the solution that NASA has solved. It's like echoing. This porous material essentially would get absorbed with plant food and water, and then the roots would absorb that, and then it would also get enough oxygen it needs for the plants to survive. The porous material we ended up deciding on was rock wool and coconut coir, but in the end, we ended up deciding on doing rock wool due to its hydroponics, water retention, insulation, and aeration, but also because of its pH stability, which ended up being like a huge factor into why we chose rock wool, because we later found a 2010 NASA article. It was 80 pages long. But essentially what it was that they were testing and trying to grow plants in rock wool and coconut coir, but because coconut coir has a low pH stability, the plants ended up dying. The rock wool did end up surviving, but both of them failed due to crystallization that formed on the surface layer. What they were doing is they were using a dropper which was mixed of plant food and water, and they were dropping it along these cubes. Eventually the plant food kind of settled at the top and it caused crystallization, so this plant eventually ended up dying due to overnutrients. So our new research question was, how can we prevent this crystallization from happening at this top surface, and also make sure there's an even dispersal of plant food within these rock wool cubes? So I'm going to pass it off to Jalissa to talk about our solution.
Yeah, thank you, Nabia. So we're going to run an experiment with 3 different conditions. The first is our control, just a mister on bare plant roots, and this, we're expecting the plant to grow successfully. This works great on Earth. We can't actually implement this solution in space because the water and air won't flow as it normally would on Earth, but this will serve as a good control. And then next we'll test rock wool with a water dropper. This is going to be exactly what was done in that NASA study. So we're expecting the same result, that the plant will grow at first, but eventually the accumulation of nutrient crystals will kill it. And lastly, we're testing rock wool and a mister system to disperse the water, which will be drawn through the rock wool with capillary action into the roots. And this we're expecting the plant to grow, and this even distribution of nutrients will prevent these crystals from forming. Yeah, so this is our space design of if we were actually going to send this up to the ISS. So at the top you can see it's a pretty standard hydroponic system, just grow lights with the plant, and those roots are anchored into the rock wool so that it can draw up humidity and water from the humidifier down below. And the humidifier is a fan attached to a wicking material which draws water up from an expandable water tank. And that's important because if we used a typical rigid water tank, as water is drawn out of it, air bubbles would form to fill the empty space, but we don't want to introduce air into the system in that part, so we use an expandable water tank that can just contract like a balloon as we pull water out of it. And yeah, this is a CAD model of our design. That mesh material at the top is the rock wool that will draw the moisture and nutrients into the plant roots. At the bottom, we have the expandable water tank, and then we wanted to include a manual on-off switch just in case something goes wrong with the sensor. It can be controlled manually so that the plant won't die and the experiment can continue. So the next steps for our project are to run this experiment that I described once our necessary materials arrive. Next, depending on the data that we interpret, we'll determine which water delivery mechanism was the best as far as high plant growth and minimal crystal formation. Next, we will improve on our design, prioritizing cost and weight efficiency. Every pound that's shipped up to the ISS is extremely expensive. It takes a lot of fuel, so really the best way to keep costs for our project low is to make it as light as possible. And next, we'll run a longer experiment to determine long-term plant viability and eventually use a CubeSat system to test our system in microgravity. Thank you. Are there any questions? Okay, great. Thank you, guys. Ooh, okay. I think that throughout the 2-year lifespan of the project, for me, the biggest challenge was learning how to build something physical when we were making our prototype last year, because I had never done anything like that. I'd never used a power tool before, so that was a really big learning experience. What about you guys?
Yeah, I would say just the reiterations of experimenting and researching and seeing what works and doesn't work, as it's in a microgravity environment. So we don't have gravity, so we have to figure out how it would work without, obviously, gravity's like input on it.
Kind of following that, I know Zach, he kind of explained like it's kind of difficult to see where the project needs to go because there's a lot of different pathways we could have taken this project. We could have done a CubeSat, we could have fixed our original design. There's a lot of things we could have done. We could have just applied for NASA competitions, done something like that. So we kind of switched our directions a lot, and it's kind of hard to figure out which pathway to take. So I'm glad we ended up choosing this and trying to do more research and see if this is a possible solution that we can pursue.
And just for our audience online, can you guys, if it hasn't already been said, tell us what year you are and then what your majors are, because this is very interesting.
Okay. So I'm Nabia. I'm a third year studying electrical engineering.
I'm Diana. I'm a second year, and I'm majoring in kinesiology.
And I'm Jalissa. I'm a junior studying biology. Thank you.
Thank you so much. Awesome. Next we have, let's see, Project Particle Analyzer.
Okay, hello again. Hope you guys aren't tired of me. As I said last time, my name is Ethan Pitzer. I am, as well as leading Project Ilion, a part of Project Particle Analyzer. So we'll get into a little bit of what that is. I heard some confusion kind of rippling through the room as we were talking about the name. People don't really understand what it is. I'll try to give as kind of high-level overview of the science as possible. But our objective is this: to research and develop a prototype of a charged particle analyzer to simultaneously measure the charge, diameter, aerodynamic diameter, and the optical diameter of a particle. All of that is just fancy terminology to essentially say there are aerosol particles that exist in our atmosphere in very specific concentrations with very specific sizes and electrodynamic properties. We want to better understand how those things operate because they directly relate to a lot of different atmospheric processes like cloud formation and things like that. Those things are huge when it comes to like global warming, radiation reflectivity both back down to Earth from the surface, and then also solar radiation being reflected back into space. So we're kind of in the modeling design phase right now. We started out doing a lot of literature, and we've come up with things like this. The start of the project actually happened about 50 years ago, so we didn't come up with this ourselves. There was somebody that showed up to us with kind of a passion project of his and decided to fund this research because he attempted to solve this problem 48 years ago, technically speaking, in the 1970s, with a patent to charge particles and then register their charges. So you get kind of a unique read of each different particle in your population. So you charge them, and then you pass them through a Faraday's cage, and then you let them kind of slipstream out. So you can mount this on an airplane or something like that to analyze the air around you. But essentially, the mock-up that we have right now is this in a CAD design. I won't go into crazy specific detail, but essentially what you see is in the middle here, the red line is a corona wire. So that's something that we are charging very specifically to eject ions, and then that charges our particle population as it slipstreams kind of into the device. We will have dried it first to strip out any chances that the particles would have coagulated. Moisture tends to increase the likelihood there. And then you get a whole bunch of other things meant to kind of stabilize that slipstream. You don't want turbulent air. There are certain effects that kind of start up there, so what you would prefer to have is very smooth, single directional air, and then that allows you to a little bit easier understand the movement of those particles and their respective charges. Then you move on to the Faraday's cage. So if you don't know, a Faraday's cage is essentially a device that you can use that has a fully neutral charge. So as a particle is passing through, registering the speed, the intensity, things like that on the particle itself as it passes through the Faraday's cages or the cage and disperses its charge, we can then understand what that molecule actually looks like. So the most important thing that you can kind of see here, oh, we lost it. All right. The most important thing that you can kind of see here, Faraday's cage issue-wise, is as you're passing particles through it and they're dispersing their charge into the cage, you have to find a way to effectively discharge that cage so that you can continuously get good readings of your particles. So you can see kind of in this left diagram here, in the top right, you see mesh resistance, mesh capacitance, and then ground. So as we're passing particles through, this has been an issue of ours. You collect the charge, you accumulate it in the cage, and then you disperse it through a capacitor, and then that gets sent to the ground. So you can get a continuous reading as you fly your device although right now we're working on benchtop designs. So, question is why? I kind of alluded to this a little bit earlier, but essentially how the atmosphere works, how clouds are formed. We have different molecules like CO2, water, salt, things like that, that exist in our atmosphere in all sorts of different concentrations and populations. But those things, the way that they are built and the specific volumes of those like molecules, they will dictate all of the behaviors of your atmosphere. So what we're trying to do is better understand what the particles are that exist in a particular area and how they affect the brightness of clouds, the existence of clouds, the number of them, and then effectively, if you're able to understand that, then we can geoengineer the atmosphere. So you would understand things well enough that you can artificially introduce new aerosols and directly control what the population of those gases are, and then choose when you want to have and where you want to have bright or dim clouds, and reverse the effects of global warming. So it's a big project with a lot of implications, but that's all that I've got to share with you today. Are there any questions? It's a good question. So actually, the original patent didn't necessarily differentiate between them. So there's a very specific size range that we were tending to look at, and that's something that's kind of still up to question. We're looking right around a micron or submicron. What's difficult is particles will, A, change size, they'll also change shape. We kind of naturally assume for the initial part of the research that you're going to have a spherically shaped particle, which is a relatively safe assumption, but you have a spherically shaped particle that falls within a very particular size range. The differentiation is something that's incredibly complex for the modeling purpose, so we start small and then we'll work our way up. So that's a problem down the line. Sorry, Kevin's hand. Yeah. Yeah, so essentially it was not a previous project for Luminosity. This is a new project for Luminosity. It was something that this person worked on about 48 years ago, because I think it was in 1977. So he developed a patent and tried to come up with an innovative solution for this issue, and it didn't end up working. He left the issue and went and worked in industry for a long time, accumulated plenty of funds, and then now he doesn't necessarily want to pick it up himself and solve all of these issues. He would much rather establish a partnership with us and allow us to then take up what he's already done, make tweaks to things if we think that there are updates that have occurred in the last 50 years, which there have been a few, but not as many as you would expect. Use modern approaches, modern technologies, and then kind of re-innovate and bring back to life his project. So that's what we're attempting to do. The next steps. So right now we're in modeling, then we'll get to the design phase. So this was a project budgeted for, I think, somewhere around 14 months. So there was a literature phase to begin, kind of understanding the particle physics behind things. That was my job as the astrophysicist to really kind of understand. Then we have Sarwan in the back, Zach, Daniel, other people on the project team that are focusing specifically on the electric field charging, specifically on the unipolar charging. So that was the first diagram that I ended up showing you on the screen. We're doing all of the modeling and simulating for that, kind of understanding how the air is going to flow through the device. And once we have effective models, and then we've got a good, like, I think we're doing a Monte Carlo simulation. So we've got a good spread of our data, what it looks like, we can actually start to build and test our device. So we're looking benchtop first, and then we would be able to do something that you could then mount on like an airplane or something like that. Any others? Okay, thank you very much.
Awesome, Ethan. Thank you so much. Next, we're going to have Project Microwind come up and present. So yeah, let's cue them up. And let's give a round of applause for Ethan as well. Thank you.
Oh, the clicker? Oh, this thing is talk like from far. Oh, okay.
Hi, everyone. I hope you guys are having an amazing day. We've seen some great projects today. And now we will present to you guys Project Microwind, which is essentially a sensor design project. And we're essentially designing a wind sensor that can estimate wind speed and direction. This is a research-oriented project that we recently started. We've backed it with good existing research. We've identified gaps in existing research. And we want to fill some of those gaps. And through this presentation, we're going to take you through where we are currently in our journey. So yeah, in terms of the team, I'll start by introducing myself. My name is Sarvan Shah. I'm an electrical engineering graduate student here at the lab and at ASU. Some of our team members couldn't join us here today, but I will let Daniel and Bilal introduce themselves as well.
I'm Daniel. I am an electrical engineering senior. Yeah.
And my name is Bilal. I'm a freshman electrical engineering student.
Okay, so the first question to ask is that why is it important to create a wind sensor? And where is wind essentially used, wind data? So wind is essentially used when it comes to studying climate and weather, whether it be forecasting or whether it be modeling for climate and stuff like that. Unfortunately, despite modern advances, the density of wind data that we have globally is at best sparse. And this is even more true for underdeveloped and developing countries, where a recent study showed that for a 7-day forecast, for a 1-day forecast for an underdeveloped or a developing country is worse than a 7-day forecast for a developed one. And that kind of highlights a critical inequality gap. And so that in itself necessitates the need to develop low-cost sensor solutions that can help us increase the density of data in underdeveloped and developing regions. No, not yet. Oh, so now that we've established some motivations, let's look at some questions. So the first question is whether is this even possible? Can you even use microphones to estimate wind speed and direction? So that's the first question that we're going to be trying to answer, and whether it can be done with a degree of accuracy that is acceptable by meteorological standards. So that is something that we will share over the next few slides. We'll try to answer these questions through the research that we've already done. So the foundation of our sensor design essentially traces back to a paper in 1964 by G.M. Corcus, in which he identified when a fluid flow or wind strikes or interacts with a body, it splits into low frequency and high frequency pressure fluctuations. And he identified that the high frequency pressure fluctuations quickly disperse over space and time, whereas the low frequency ones don't, and thus you can correlate them over space and time. Then later on, another paper identified that the dominant source of wind noise in microphones are actually those low frequency pressure fluctuations that we just discussed. And so how this integrates into our sensor design is that when you have two closely spaced microphones, you can capture wind noise in them, and you can correlate that wind noise. The amplitude of those correlations gives you the wind speed, and their phase gives you their direction. In terms of other studies that have tried to utilize this idea, in 2005 there was a study that came up with a mathematical model for these wind noise correlations and used those to estimate wind speed. They identified that the sensor spacing, the spacing between the two microphones, was a critical parameter, a critical variable in terms of the resolution you could resolve the wind speeds with. For example, if the sensors are really closely spaced together, you might not be able to resolve high wind speeds, or if they're too far apart, you might not be able to identify slow wind speeds. Another study in 2014 tried to use ambient noise to estimate wind speed, and how that worked was that, they used ambient noise and tried to see the time delay between they tried to estimate the time delay between one microphone and the other it took for sound to reach from one microphone to the other, and use that to estimate wind speed. But that we don't think is a generalizable solution, because ambient noise might change with the urban environment or the acoustic environment around it. In 2020, another study used a deep neural network, which is something similar to what we're trying to do, to estimate wind speed using closely spaced microphones, but they only got fair results, and that too with only significant temporal averaging, and we want to kind of improve upon that. So we've answered the first question, that whether this is possible or not, and we've seen in existing literature that there is a sound theoretical basis for such a sensor design. So the next question is that can it be done with a degree of accuracy that is acceptable by meteorological standards? And so standards for us, we have chosen the World Meteorological Organization standards as the standards we're going to benchmark our research against. And some of those standards are highlighted over here, such as the wind speed uncertainty that is acceptable, or the wind direction uncertainty that is acceptable. And so these will be our guidelines for the research that we're conducting. Now I will pass it over to Daniel, who will kind of highlight where we are and what we're trying to do.
Yeah. So for our approach, or I guess let me start with the experimental setup. So our research setup timeline is basically going to span a year. And what we plan on doing is collecting data and using a convolutional neural network rather than a deep neural network, because the deep neural network it's not as accurate, based off the research that we've done in the paper review. We're going to use that to capture spatial information and audio data for increased accuracy, like I just said. And then we're going to perform experiments to kind of like validate that hypothesis. And then we're going to test the sensors and make sure that it meets the WMO standards. All right, so we're going to have two phases. We're going to have one phase in the lab, the second phase outdoors, obviously. And so for the indoors, we were able to get a sounding room, courtesy to Dr. Boss and Dr. Patton. They're both doctors of audiology and the College of Health Solutions. We're able to use their room to do our experiments in the first phase. So we're going to use a TerraBloom silent fan. The reason why we're using a silent fan is because fans off the market, they generate too much acoustic noise that the mic will pick up, and that will overpower all the other stuff. And for the wind, so the silent fan is also connected to a wind duct, and on the other side of that, we're going to have the data acquisition stuff. So like the STM32 microcontroller, and then the microphones. We're going to have two MEMS microphones. They both have a sampling frequency of 2 kilohertz, and then the reason why we have that in the first place is because based off the research we've done in the past, we understand that wind noise manifests itself. It's proven that it manifests itself at frequencies below 1 kilohertz. So we want to sample double that frequency to ensure signal integrity. So yeah. And then we're going to use, for our control sensor, we're going to use an ultrasonic anemometer. And that, I believe the accuracy of the anemometer that we got is like 3%, which is really good. It meets the standards. And we're also using a hygrometer, which is a humidity sensor, and a thermistor for temperature sensing. And then, yeah, so for phase 2, we're going to go outside. We're going to use all the same equipment, except that instead of obviously the fan, we're going to use natural wind as our input to the system. So yeah, we have all the same sensors and stuff like that. Now we just have to consider, does this actually meet the WMO standards? Yeah, so I'll hand it off to Bilal to talk about the cost and all the other stuff.
Okay. One of the best parts about our research is its ability to be very impactful. Due to the low cost of the wind sensor, it means that weather data can be more accessible to people all across the world. In addition to this, the cost of conducting research is also pretty cheap, about $2,500, and most of that is coming from high accuracy wind sensors to confirm our results. So for the future scope, we plan on testing different variables like the distance between the microphones, maybe the orientation, the height, and then also testing how humidity and temperature play a role in the accuracy of our results. We also plan on testing how microphones could be used to estimate humidity and temperature, potentially. In conclusion, our mission is to enable more accurate tracking of climate change and increase the availability of weather data to people who need it. And through this project, we hope to develop a low-cost, accessible solution to wind speed and wind direction measurement. Thank you.
Thank you.
Questions? So the point of the neural network is that since this problem involves turbulent flow the wind that we're dealing with is inherently turbulent, and there's no mathematical model with which you can capture that, or you can, define the relation between turbulent flow and then the wind noise the microphone captures. It's a difficult to define, a very nearly impossible to define problem mathematically. At best, you can get estimates based on assumptions, and we know that deep neural networks have a lot of modeling power that we might not be able to get through a mathematical model. And the idea is that instead of trying to define a mathematical model ourselves, which would have a lot of assumptions, we skip that part and we feed data to the deep neural network. And the idea is that once we have enough data, the network itself will learn the underlying model, and that way we can get good results.
And we're feeding spectrograms into the convolutional neural network, so it does it's basically like image processing.
Any other questions? Yeah. So current, like the ultrasonic anemometers, they cost anywhere from $400 to thousands of dollars, especially for wind sensors that have no moving parts. Like you can get other wind sensors that do have moving parts and are cheaper, like in the order of maybe $50, $100, but they have moving parts, they have maintenance needs, and they aren't as accurate. But with this, the cost could be in the low 50s, the low 20s. And it would be significantly more accurate with low maintenance needs. So, yeah. Yeah. It would be nice to go to a different location, but we're probably going to start off with Arizona and see how that works, and then maybe we can move to another location and test there once we're moving down the line.
Chicago.
Yeah, Chicago. Yeah.
Do you guys planning to add some noise into your training data to allow you to handle the ambient noise that you get from in-field testing?
So not in the first phase of the project when we're testing it in the laboratory setting, but once we're in the second phase, we're going to be testing it outdoors, and then ambient noise is going to be inherent. But the underlying theoretical assumption is that wind noise manifests itself in low frequency, whereas a lot of ambient noise might be more higher frequency. But again, that is a research question that we will be exploring, and if there is ambient noise that is contaminating our data in the outdoor environment, then that is something that we will find out, and we will have to look for ways to address that. Yeah. Is that it? Thank you. Thank you.
Thank you, guys. All right, so we are going to take a 10-minute break, and then we're going to get into an activity. We have some guests here, so I would highly recommend, go to the bathroom, get some water, whatever, but also stand by your projects and be ready to showcase the great work you're doing. Yeah. So, 1:45, let's circle back up. How's everybody feeling? Woo! Thank you. Long day, huh? Tomorrow's even longer, which is so exciting. No, honestly, it's gonna be so fun. Like today is internal, but tomorrow we face the world and literally change the world. Get it? So thank you. But honestly, I just want to say, like, as staff, we're so impressed with each and every one of your presentations. Like, you guys have done an exceptional job putting these together. I know it wasn't easy. I know this last 2 semesters has been crazy, but you guys are absolute rock stars and you represent everything that Luminosity stands for, so thank you. Round of applause for each and every one of yourselves, and just today. It's been awesome. So yeah, you guys should be super proud. I'm super proud. And I don't know if I have, but I'll post a live stream link on Slack. So share it with your parents, your professors, everyone, so they can see the great work you're doing. And that being said, we are right on time. I love that. Yes. Gonna get started with Aegis. Yeah, so you guys can take it away.
Thank you. Oh, clicker. Perfect. Okay, hello everybody. For those of you who don't know me, my name is Grant Leslie. I was the project lead for Aegis, our submission to the 2024 NASA Big Idea Challenge, where we developed Aegis, the inflatable lunar landing pad. So for those of you who don't know, we'll stay up here for just a second. The NASA Big Idea Challenge is run every year, and they have some prompt for colleges and universities across the country to try and solve. This year it was inflatable structures to solve some problem on the moon. After a month of ideation and design, we landed on the problem of harmful regolith ejecta that are created during landing procedures on the moon. So specifically, we were looking at what are called CLPS, or CLIPS landers. So these are like the UPS trucks to the moon. So companies contract other companies to just take up their payloads. On the surface of the moon, there's stuff called regolith, super sharp, tiny sand that has electrostatic cling, and it can reach speeds of up to 2 kilometers a second during these just small-scale landings, which can sometimes send that regolith into orbit, damaging spacecraft and other instrumentation. Obviously a very bad problem. You don't want super sharp sand everywhere all the time. So we were tasked with designing a lander, or a landing pad, to block this lander exhaust from ever reaching the ground, thereby reducing all the ejecta. So with that, we produced Aegis. So after 7 months, we had designed, tested, fabricated, and you'll kind of see that throughout the course of this presentation. But on a whole, Aegis is made up of 5 separate subsystems. So it has an aluminum enclosure, which encompasses all the inflated components, as well as any stored gas and precious electronics. It has a heat shield that takes the brunt of the thermal loading from the lander coming down. This is made with some super fancy like carbon-carbon composites and RVC foam to handle those temperatures of upwards of 3,000 Kelvin. That brings us then to our inflated skeleton, which is created out of Kevlar inflated tubes, which can be shrunk down and packaged very small, and then when inflated with nitrogen gas, expand out to establish a near, I believe it's like 10 times increase in coverage on the ground. Surrounding those inflated skeleton members is a tarp made out of a variety of composite materials to handle both the structural and thermal loading cases that it's going to be experiencing during landing. And finally, there are a series of 6 base anchors inside of the system, which helps keep it rigidly affixed to the ground. So the actual process for Aegis is it will be delivered on a CLIPS lander away from any working zone. Then a rover will deploy it, or take it to its deployable area. Once it is set down and the rover is driven away, its central anchors burrow into the ground, stabilizing itself, and then our deployment process begins. So Aegis's enclosure is sprung-loaded, so all of the exterior panels will open up, and once that is done, the internally housed gas makes its way out to the inflated skeleton, slowly establishing its base, until finally it is fully pressurized, and the upper deflector rings inflate upward, and it is fully established and ready for a lander. Then a lander will approach, and as it descends, all the exhaust gases get kicked up off of the rim or deflector of Aegis and away from the surface. So our simulations show that this was a 96% decrease in fluid shear stress on the ground, which we equate to regolith kickup. Once that's done, the exterior walls are able to be deflated without deflating the rest of the structure. This allows any cargo or payloads to be brought off of the lander, and then cool. And then imagine they get reinflated back up, and the lander is able to take off and land a farther distance away from the work site, where it will then stay in perpetuity. So yeah, I'll hand off to Connor to talk about our procedures.
Thank you. Alrighty, so there's kind of a lot to go over with manufacturing since the system is very complex and has many different components. But in the top left, you can see Takia manufacturing the tarp made out of a knit carbon fiber material, and then below that are some of the electronics with a whole lot of different controllers for all the. We have 6 servos, 6 motors, bunch of pressure gauges because of the inflatable system. Just a whole lot of stuff that's R1 masterminded. And then we have the enclosure with its panels and right in the middle on top. And we have me and Grant holding our homemade inflatable system because we had a little bit of trouble with the inflatable system, so we had to make our own like 2 weeks before. But we rocked it. It was amazing. Came up, pushed new boundaries. And then on the far right, you can see it deployed in SB Crater in Flagstaff. We chose that location because it has a volcanic stuff there. Volcanic like stuff in the dirt. So it's really abrasive and very similar to regolith. That's what NASA does. So for laboratory testing, we started off by testing the beams. On the left, you can see a compression testing, which is kind of like what would happen if a lander sat on the beams. Right? We want to make sure that that's strong enough, and it was. I don't remember the exact same like numbers, but it's good. And on the right side is testing to see kinking. Basically, if you guys have ever had like a balloon or anything like that, and you try and push on a little bit, like it's got a little bit of rigidity, but once it reaches a point and it kinks, it just breaks basically, or buckles. And so we were able to do that, and you can see on the outside there's a Kevlar kind of sheath to give better rigidity and support, and then the inside is the tube made out of ballistic nylon. Here we have the tarp structural testing. You can see a GIF here that's going to be going over and the different points where the different composite materials will break. You can see that the alumina felt fails first, and then that's followed by a Kapton, and then that's followed by the knit carbon fiber unraveling, which kind of gives it that slow falling off. And as well, we did thermal ablative testing, which is basically just, is our heat shield going to be a heat shield? So we underneath an argon flood, so that way it doesn't kind of burn up. With any oxygen, we put a torch on it, and it was able to withstand it for, I think, an indefinite amount of time. It was fine with a zirconia coating and then RVC foam underneath, layers. Then base anchors, my specialty. We did 3 different types of testing. We did deployment testing, lateral pull-out testing, and then vertical testing, and designed 2 different styles of tips with helical inspired, like helical pile design, and then we also tried a wood screw design to increase deployment depth, but ended up only achieving a 2/3 light deployment with a lot of torque, much more than we thought. As well with the electronics validation, we did it step by step of how it would actually deploy. We made sure that the base anchors would deploy, and then using motors and specified torque for what we thought was going to be necessary. And then we tested the tarp releasing mechanism with the 6 servos, and then the tarp inflation with the bang-bang control mechanism of our electronic pneumatic control system.
Yeah, so all of these were our laboratory testing where we're simulating relevant environments. We will now take ourselves out to the Earth analog testing. So this is kind of how testing is structured to progress these technologies from just a simple ideation to all the way up to in use in space. So our Earth analog are more immersive. You will see in the first one some very fun pictures. So this is where we did our rocket fire testing at Friends of Amateur Rocketry in the Mojave Desert. We got a solid rocket motor, and we were able to take out one version of Aegis out there and fire directly down onto it. So you'll see, we will get a video after this, but you can see, you're going to watch out in that video for that top right freeze frame. of our gases successfully getting deflected upward and away from the surface. But I will hopefully... Yeah, are we moving? One more. There we go. We're going to a little countdown. This is super fun. And... I mean, that's pretty cool. That's pretty cool. That was one of the most fun tests that we got to do. We were able to show that successful deflection. Not pictured here. If you're interested in seeing the collateral damage afterwards, feel free to swing by. I have some fun videos. But this was still categorized as a successful test, and we were super excited to move on from that into our deployment testing. So I've got just a video here. This is when we were out at, not SP Crater. Yeah, SP Crater, yeah. And we did our actual deployment testing. So this was, you can see Star 1 there stepping through all of our procedures. We're using servos to actuate the panels. So those sprung outward, and then you will see the system slowly expanding as we are introducing compressed gas into the inflated skeleton. You'll see one of the nice things about these inflated structures is they're very compliant. So even when certain parts of the system got caught up in a couple locations, you'll see it is able to kind of move out of the way, which is really nice for consistency, especially in a circumstance like Zach had mentioned earlier, where it has to work on the first time. Getting that additional compliance is very nice, and you'll see it slowly start to expand out until we are fully established, as the last one goes. So yeah, after this is our final deployment testing, which pushed us into TRL 5, which is just on NASA's scale from 0 to 9 of technology readiness. So we were able to get a 76 deployment time. We had minor debris in the area, and it was also deployed in an incline. We were super excited about all this, and it was a nice way to wrap it all up. So with all of that, we were then taken and got to present all of this at the NASA Big Idea Forum in Vegas, as well as present at the Lunar Surface Innovation Consortium and their fall meeting, also in Vegas, where we got to talk to a lot of people about this possible technology. So with that, we'll end on a fun little shot that I always love to see. Yeah, that wraps us up. A special thanks to all the people who are working on it, especially our advisors, James Bell, James Rice, and Mr. Tyler Swift. Sorry, Dr. Tyler Smith. Yeah. So yeah, with that, thank you for your time. Any questions? I know for me, some of the most fun was also the most stressful right at the end, when we were dealing with production delays, which kind of ended up translating into just a lot of time in lab, and getting the final push of, hey, we have one weekend to do rocket fire testing and deployment testing, and the rocket fire testing, we can't be confident that's going to survive, so that means we have to make a whole nother version. So it was finish manufacturing one, manufacture a whole new one, and do both of those final testing with, I think it was 5 days until the final report was done. So I advise not doing that, but it was very fun nonetheless.
Oh, me? I think the most fun was just being on a project like that for the first time for me. Like, that's the first, like, this is like NASA. This is really cool. So it was just an amazing experience, even though a lot of it was hard work. A lot of it was like, man, this guy he stayed up for 40 hours straight. He's the goat. He's the goat. I love him. So a lot of it was hard, but also kind of want to work at NASA now because this stuff is so cool. So, yeah.
Well, perfect. Thank you.
Awesome. Thank you so much, Aegis team. While they pack up Aegis, we're going to welcome the Verdant team on stage. This is very exciting.
Hi, I'm Ellie. I'm a junior studying chemical engineering.
I'm Christina. I am a senior studying mechanical engineering, minoring in sustainability.
And I'm Grace, and I'm a senior studying economics and sustainability, and we're the co-founders of Verdant Fresh. So Verdant first started here in the Luminosity Lab back in January 2023 when a group of us were really interested in looking at this intersection between food waste and food insecurity. So what we became really interested in is in this fact that 1 in 8 people are considered to be food insecure in the US, yet over 40% of food goes to waste every single year. So our solution to this is Verdant, a fresh produce vending machine and a food tracking app.
The first part of our solution is the fresh produce vending machine. So as you can see here, this allows you to purchase individualized portions of produce, and these machines would be located in high density areas. So think apartment complex, residential areas, on your way home from work, so that if you wanted to make a quick recipe and you needed a tomato, you could go grab that. If you wanted to grab an apple as a snack, you could grab that. Really easy to locate areas. This helps reduce overbuying, so you can buy at ease whenever you would like, and also eliminates that unnecessary plastic packaging on large quantities. And I don't know if the video is going to play, but yeah, it's not going to play, but that is our conceptual prototype for the bin motion. Basically, an arm that's mechanized in the back goes and grabs a bin, brings it to the output at ADA compliant height so that you can go and actually pick the produce that you want to purchase, so you don't lose that option of choice. It records the weight, so you just pay by weight through the card or the app, and each bin is temperature and humidity controlled in order to maximize the life of that produce. And with that machine, we have a provisional patent granted currently.
So the second part of Verdant is our food tracking app. This app allows users to scan their grocery receipts, and then it will log all the produce that you bought, track its expiration dates, and give you recipes to use your produce before it expires. Other features of the app include meal planning, automatic grocery list generation, and food storage and preservation recommendations. The app also seamlessly integrates with the vending machine. It tells you where the nearest one is, what produce is currently stocked in it, and it allows you to pay for your produce. So this is a little bit into our markets. Our target markets are broken into 3 parts, the first being food technology, the second being vending machines, and the third being green and technology sustainability. We know that there's a lot of food tracking apps on the market right now, but when we looked into it, we saw that most of these were focused on diet culture or weight loss, where Verdant falls at a really interesting intersection between sustainability and food tracking. And then lastly, our business model is 3-pronged, the first being our premium monthly subscription plan for the app. The second is advertising that's built into the app and then also on the vending machine. And then lastly is our revenue that's generated through our produce sales.
So right now we're at a really exciting point in Verdant's progress as we're looking to pilot our app this semester. We have a great team of back-end developers and graphic designers that are working with us to solidify our front and back end. And as you can see, this is kind of what's on the forefront for us in the next coming months. So also this is really exciting to announce that in the coming months we will be asking for your help to be involved in our beta testing, so look out for that. And then kind of what's on the horizon on a more long-term scale, we're looking forward to purchasing and finally finalizing our vending machine in 2026. And we also have really exciting partners that we will be working with this on. For example, we've worked out a deal with the Phoenix City Hall, LA City Hall, Mirabella, and so we're really excited to get our Verdant machines placed there.
And as for our progress since our founding, we've competed in many competitions, both local, national, and even international levels. And so far we've raised about 400K in grant funding. Oh, 40. Sorry. Yeah, not 400K. We'd be rich. Yeah, that would be amazing. That's the future. 40K in grant funding that's gone to the building of our prototypes, the funding for all of our marketing and advertising and things like that, and paying our developers. And we also want to thank our amazing mentors. We have a widespread of mentors covering entrepreneurship, which is Chris and Joan, as you see up there. And we also have a lot of technical mentorship to help with the development, which would be Mary and Josh, as you can see up there. And yeah, we're the founders. As we mentioned, we have a wide variety of experience. Ellie's our CEO, I'm our CTO, and Grace is our COO. But we do a lot of odd jobs. We kind of do it all. And yeah. Thank you, guys.
Thank you. Any questions? Yeah. Mm?
What's offered with the premium? Sorry, with the premium subscription, and then.
You think about the second. The first question, what's in the premium, is there's no advertising when you pay for premium. There is access to the actual receipt scanner, otherwise you'd have to manually input your produce. And then it also gives you unlimited access to our recipes. Yeah. Yeah, that's a good question. Do you want to answer?
Yeah, I can answer. So right now that's currently Ellie and I's thesis project, and our advisors are Dr. Josh Wilbur and Mary Hinsey. So we're working on temperature controlling the bins. So overall, the machine itself would have an air conditioning unit just like any vending machine you see, but each bin would have additional thermoelectric modules that would adjust based on sensors in the bin to the ideal temperature of each individual produce. So if you have apples in a bin, they need to be at 78 degrees. We can adjust it to that. We're also working on humidity controlling, as well as tracking through like methane and ethane gases when produce is about to expire, and kind of creating a better predicted model based on that than what's currently on the market. Yeah.
Thank you.
Hey guys, we're going to kick out the space panel in a minute, so if everyone can make their way to the seated area. But before that, we have a little something that we'd like to do. So
we have Dr. Rund and Dr. Dickerson here from the EOS department. So why don't you guys come up? I'm going to make you come up here. You don't have to make a presentation, but something that Dr. Rund emphasizes over and over again is that the university's mission is a student development organization. And so if you can just kind of walk through that concept with the students, I think that would be really impactful for them to really hear that perspective.
Well, universities do a lot of things, right? And you're evidence of that. Congratulations, by the way, to each of you for the fantastic work, the great ideas, the hard work and effort, the industriousness. We need your solutions. Like, we need some of them, like, tomorrow. And we all know that, so congratulations and hats off to all of you. What Tyler's talking about is, what's at the core of a university, teaching and learning, of course, but fundamentally, as much as we do as an institution, we're a talent development organization, don't you think? I mean, we're really investing day after day in building human potential. You're examples of that. I was just talking to the last group. We were talking about learning styles, and that was all about talent development. That's all about trying to reach a learner where the learner is and draw them into the subject matter to help them realize their full potential. That's the great thing about the work that you do with Tyler's leadership. Luminosity is the best laboratory we have for you to explore your full potential, to pursue your ideas and your passions and your dreams. That's what great universities should be about. And so we're just really proud of the work that each of you do, and collectively how important it is to the institution. Because you're a manifestation of all that we value and all that we strive to be. And we couldn't be more grateful for your efforts. So thank you for spending some time with us today.
All right, we wanted to present you with something. We have something for both of you, so stay up here. Yeah. So I had mentioned that we had printed that deck, right? That was basically a review of the entire year. So we have that for you and for the EOS department. And then we have something for, I think there's a shirt in there. If that's the Luminosity shirt. There's, I think you have a water bottle. Dr. Rund already got a water bottle, so we have one for Barbara. So he didn't get a water bottle, but we did print that out, and it's a booklet that you can keep in your office to showcase. We did also print one for, there's a pin in there, a pin in there with the Luminosity logo on as well. We did print a book as well for President Crow, so we have that, so we can give that to him or to his staff to then give it to him. And each and every one of the students here signed both books. So so it's a really cool piece of just an overview of all the projects this year, as well as the students that are in the lab. And so, but we really appreciate all of your support, and thanks for coming by. So, yeah, thanks. Do they know?
Do they know anything else about what happened today?
Oh, that I defended? Yeah. So, yeah. Thanks. Yeah. I gave the key, kind of the intro presentation this morning, and then I was like, okay, I'd love to stay, but I got to go defend my PhD. I'll be back this afternoon. So, yeah. That's right. So I think now it's the space panel. So let's have Colton and Zach come up. We've got Kylel and Lan on the Zoom. We got microphones up here already. Yeah, you're good. There should be two for you guys. Do we have them on Zoom? Okay, let me grab.
Are we muted? I think there's.
They're muted. Okay.
Oh.
Lan's coming through somewhere. All right. Well, they're getting that sorted out.
How about that?
Oh, I think mine was off. Okay, there it is. All right. Well, thanks everyone for joining. So the purpose of this panel is really kind of the kickoff for the panels that we're going to have tomorrow. So starting today, we have the space panel. Tomorrow we have a number of other panels. I think emerging technology. We have a panel on like community engagement. So we have a couple of different panels, and the goal of these panels was to bring just different perspectives, right, to these different fields. And so last year we did this. We had the space panel, and we got to talk to, I think Kal-El was on that panel. We had Jim Rice on, who's a professor here and was part of the Aegis and Charlotte projects. And we had, just kind of this general perspective of the space industry from the, in different industry, from NASA, from the academic side. And today, when I was putting together this panel, with thinking about who to invite, I was like, well, we now have enough former Luminosity alumni in the space industry that we should have a panel made up completely of alumni. And I think, so I sent a text to Kal-El, Lan, to Colton, and to Zach, and I was like, are you guys, you'd be on the space panel? And it was like immediate yes by everybody. And so excited to have everyone on. I'll have everyone kind of give a bit of bio and background for yourself. So let's just start with that. Let's start with Colton because he's on the end, and we'll go Zach, and we'll go Kal-El and Lan, and then we'll just kind of go around there. And then the questions are going to generally be related. You don't have to worry about this now, but tell us a little bit about yourself, what you currently do in the space industry. Tell us what your degree was here at ASU. And we'll just go from there. So, yeah.
Hello, everybody. Let's see, I graduated about 3 years ago from the ASU Polytechnic. I got a degree in automotive systems engineering with a focus in mechanical engineering. Fresh out of college, I got a job at Nikola Motor Company, rest in peace, now bankrupt, but got a lot of valuable experience from that. I now am in the space industry with an automotive engineering degree, so that's cool. I do control systems for fuel cells and space application. I can't necessarily say where I work, but LinkedIn will tell you.
Thanks, Colton. Yeah.
Awesome. Howdy, everybody. My name is Zach. I've been in the Luminosity Lab for 3 years now, originally working on projects like Charlotte and Axon. This is the last year of my master's, so unfortunately I am graduating. But Charlotte was a great opportunity because it allowed me to network with industry professionals at the NASA Jet Propulsion Laboratory. So 2 years ago, I was invited to have an internship with them, and they kept me on as an academic part-time while I finished up my schooling. So I've been doing that for about 2 years now. My actual day-to-day is a lot of simulation support equipment for next-generation avionics, which is a really fancy way of saying that we're basically trying to model the dynamics of a spacecraft before it actually goes out there.
Awesome. All right, Kal-El, you want to go next?
Yeah, sure. Can you guys hear me okay?
Yep.
Nice. My name's Kal-El. I graduated, I guess, 3 years ago, I think, with my bachelor's in engineering and robotics concentration, and then my master's in robotics and autonomous systems. I worked with Colton and Zach and Leanne. It's good to see you guys again. And right now I work at the NASA Langley Research Center for a team called SciFly. And we take airborne and ground-based thermal imagery of different rocket launches and capsule reentries for NASA and like other kind of private companies, which are like getting their stuff up and running, and calibrated thermal. So I kind of do a lot of my day-to-day is data analysis, radiometric modeling, and instrument calibration. So really trying to get that data from those pixels as good as possible using cool techniques and stuff like that we can find in today's AI space. So that's cool. And yeah, I think that's about it.
Awesome. Thanks, Kal-El. Leanne, you're next.
Hi, everyone. I'm Leanne. Can't really see you guys, but I hope you guys are having fun. I know we all did. We all went to ASU together. I also went to ASU Poly. I was in the robotics program with Kal-El as well. And I actually ended up getting my master's here. I'm in Los Angeles at University of Southern California in electrical engineering. And then I ended up very fortunate with a position at Raytheon which is now considered RTX, or that's their new name. And I work specifically with space and defense technologies. And a lot of the work I've done has mainly been centered around testing and testing a lot of this flight hardware that's going up into the air in the next few years, actually. But also the benefit of working for a corporation like RTX is I do have relationships with Collins and Pratt Whitney. And so that is also something that is a part of my day-to-day is right now I'm actually working on projects with Collins Aerospace. So it's very nice to see how ASU just kind of, and Luminosity obviously just like launched me into this career that I never thought I would actually be a part of. And I think we can all speak to that.
That's actually the perfect segue into my next question. So the way we're going to do the questions, we're going to basically boomerang. So you're going to answer the next question first, and we're going to go backward through everybody. So that the next question is literally, how did you get first interested in the space industry? So walk us through that origin story. For some people that maybe, you know, they dreamed of being an astronaut when they were a kid. For other people, they got thrown into it or just arrived in that career. We want to hear the different ways that people have gotten into the industry and what that looks like.
Cool. So starting with me?
Yep,
or
back to you. Yep.
Okay. So full transparency, like I knew I wanted to be an engineer when I was younger. I was very fortunate to have mechanics around me my whole life, but I never actually like knew or wanted or made for sure that I was going to be in space or defense or I don't know, tech. I think for me, what it was is I just realized I had a skill set and I really enjoyed it, and I just wanted to apply it somewhere where it felt meaningful. And actually, that's why Luminosity means a lot to me personally, because the opportunities that kind of just came about to the lab really just influenced me to try anything and everything. And I just noticed I felt the most meaning through the space projects that kind of came our way. And when I got my job with Raytheon, actually, I thought I was going to be on the defense side, not necessarily the space side. But it's funny how it worked out. I actually got transferred into the space program sort of later after I joined. And I don't know, like my personal opinion is I think it was kind of just meant to align that way for me. And it was more about just focusing on like what skills do I have and what do I want to keep doing. And then everything kind of just fell into place.
That's great. So when you were here, you were working on Velos. So that was the first NASA project that we did. And that was during COVID, and it was a wild time because we developed all of that remotely and built it and then tested it during that time. In your role at Raytheon, can you tell us much about what you are doing, or you're like working on space lasers, you like can't tell us?
I can give you a general idea. So the program I worked the most with, and I still do a little bit of work on right now, is actually a project with it's spearheaded by United States Space Force alongside Lockheed Martin and Northrop Grumman. And if anybody's been to Los Angeles and the El Segundo area, it's just all of these companies were all literally like one street down from another. And so the program that kind of came around, I think it was like I think it might have been during COVID, was basically this push for satellites and satellites to help our defense systems detect certain things. And so a lot of the technology that I work with is actually for satellites that are used for detection.
That's very cool. Kyle, up to you next. So tell us how you got interested in the space industry and what that looked like and how you first arrived there, I guess.
That's an interesting question for sure. I would say I was originally like not that interested at all. Especially like definitely when I first met Tyler, when I first kind of became acquainted with Luminosity, I went to school my major was robotics, and I was super into robotics. I was working on a lot of robotics for the lab, and I wasn't more so interested in space because I was just kind of like technology in general and maybe robots for space. But I ended up kind of finding a niche in my studies for image processing and computer vision and like AI that had to do with like vision models, foundational models at the time, and just a lot of like my class work and extra class stuff was focused like just in computer vision. So I ended up getting an internship at NASA Langley with some people that I currently work with to do a lot of kind of processing some of the data that they were running. And it's for the group that I currently work with, the sci-fi team. And yeah, we take like airborne imagery of different things, and a lot of times trying to get like that data to show you accurate temperature measurements from just an IR sensor with the telescope in front of it can be really involved. So the skill set that it took, kind of like what Leanne was saying before, the skill set that the lab and like ASU allowed me to kind of cultivate for myself, just through trial and error and stuff, was really something that I found like a niche for was actually like needed in my space at NASA Langley. So my internship rolled up into a full-time, and like that's where I currently work. So I think I definitely kind of grew an affinity for like the space industry. But I definitely wouldn't have had like opportunity at all if it wasn't for a lot of just the really long hours at Luminosity and ASU. So it's been pretty cool.
That's good to hear that that really panned out. Last year, you were telling us that I think you guys had the Sci-Fly system at one of the Starship launches, right? Have you been on there to see a Starship launch yet, or were you there, or did you have cameras there at the last launch where the Starship booster landed, Starship didn't?
Yeah, that's a good question. I have not gone out to see another Starship launch yet. We were there for Starship Flight 7. My team is, yeah, we like specialize in thermal. So usually people want us to take pictures and video so we can extract thermal of significant events. For Starship, that's almost always like when the two separate from each other, or when the one, like this actual Starship, is landing, or I guess for right now, like re-entering. So we're actually based out in Australia for Starship Flight 7 and waiting for it to come back. And I remember watching online and saying that they had lost Starship, and I was like, what do you mean you lost it? Like half of my team is over there just waiting on the Gulf Stream for it to come back so they can like take infrared imagery of it. It was completely gone, but we were prepared. We're still working with them to kind of like explore like their like next launches and stuff like that. We were taking imagery of the booster, and we were able to capture like that and it coming back. We also were there for the Blue Origin New Glenn launch, so we saw that separation booster come back and everything. So yeah, but that's been, I would say this past winter was very, very stressful for sure. With all the delays and everything like that.
So you guys have a plane that these thermal cameras are mounted on. So you sent the plane to Australia to just record the landing of the Starship, right? And then does the plane just stay there? Is it just going to stay and hang out there, or you guys bring it back? And does it get flown there? Like a pilot flies it there, or do they transport it? I guess it's too big, because I've seen that plane before. It's too big to put on any other aircraft.
Yeah, so right now we have like a few platforms using a few different airplanes for that observation. We're using a Gulfstream 5. So we did actually like fly it from where it's based at in the States to Australia. It was kind of like however you think you would fly it commercially, basically, is kind of the path that they took. They were out there for a few days, getting everything ready to go. And then the landing site was kind of like in the middle of the Indian Ocean. So we were based out in Australia, and they flew like out towards the landing site and then came back, or that was the plan. And we have like holding patterns and stuff like that. So they held for a minute, found out that it wasn't going to come back, and then came back to Perth, and then like flew it back to the States. So that's usually our ConOps. Wherever stuff is coming back from, we'll fly the aircraft with the imaging payload out there, prepare out there, fly it to do the observation, and then fly it back to wherever it's based.
That's really cool. Well, we could probably talk about this all day, because I think you guys all are doing really interesting things. So let's go to Zach and get your kind of story into the space industry, and then we'll do Colton, and we'll kind of continue on. So.
Yeah. So originally, back when I was still in elementary, middle school, and high school, I started out doing FIRST robotics and really got exposure into the robotics industry. So fast forward to my undergraduate degree, I switched over to cybersecurity and realized after working on Charlotte that cybersecurity is probably not the career path I want to go into. I really enjoyed getting to work kind of hands-on on projects, doing electrical engineering, getting to work a little bit in mechanical, and still having a real passion for software. So I switched over for my master's into robotics and autonomous systems, and Charlotte helped me realize that space robots actually do exist, and a career at NASA is not just building rockets or having things on the ISS. The Jet Propulsion Laboratory actually specializes in robotic exploration of distant planets. And so that's kind of how I got started into that and fell in love with it ever since.
Nice. That's great. Yeah, I think that's a really unique story. I think, we've had a number of students who have come through the FIRST Robotics program. It's a phenomenal program. And then kind of seeing you go from, computer science back into robotics, and then your internship at NASA, I mean, it's been really awesome to see. So, Colton, let's hear your story.
Yeah, so for me, honestly, like, for as long as I can remember, like, growing up, being in the space industry was what I wanted to do. It was always something that fascinated me, and for some weird reason as a kid wanted to push the boundaries of space and explore the unknown, the new frontier, because that's what felt like what was left in our time. So growing up, I had a real affinity for it. If you've ever seen the movie October Sky,
Yep.
sold me on it.
Anyone seen that?
Yeah.
Anybody? You should see
If you haven't seen it, definitely give it a watch. It'll make you cry.
Yeah, it will make you cry. Yeah, won't give it away. You
Yep.
guys should all watch
Yep.
it. New homework assignment. Go watch it.
Yep.
Okay, back to your story.
So growing up, had an affinity and just kind of innately loved science and problem solving. But at the same time, growing up, I was really good at soccer and put my focus into that. So I kind of regressed in, I guess, my trajectory for what I wanted to do and lost sight of that. And fast forward a ton of years playing soccer, really good at it, but then had a future with it, and then had multiple, more than multiple concussions that kind of came to a point where I was like, I should probably use my brain while I still have it. So then basically first year of college, I was playing college soccer, dropped kind of the path I was on, and then came to ASU and decided to become an engineer. And growing up, I had no reference for what an engineer was, what an engineer did, but I knew they solved problems with math and science, and I said, okay, cool, I want to do that. That's what I like doing. Again, space always on the back of my mind. That's what I want to do, but I felt so, I guess, far behind that I never thought being in the space industry was, I guess, in my future. So I worked really hard. I got a degree in automotive engineering because I can actually touch cars, I can drive cars, I can work on cars. It was familiar, and I like doing it as well. But throughout my time at ASU and in Luminosity, I got to work on some projects that were like space-centric. So I forget the name of it, but it was the like star tracking telescope camera mount.
Yep.
Got to work on, and then some other aerospace projects such as the HADAR drone.
Yeah, it's
yeah,
actually
it's
going over there.
Yeah. So that was really cool. But at the same time in Luminosity, and I guess prior to Luminosity, what got me into it is I, again, didn't really know what an engineer was. I didn't know what a controls engineer was, but I started solving problems, starting projects that involve software and autonomous systems and mechatronic systems, all that. And I just loved it, and I kept doing it. And then that got me into Luminosity on Trident 1, and that kind of built up my skill set even more with autonomous systems, robotics, all of that. And then that cascaded into me getting a job at Nikola Motor Company, again, RIP, where I got more experience being a controls engineer. And basically I was not fully satisfied. Like I knew deep down I still wanted to be in the space industry. So, I'd always kind of peruse LinkedIn, see what was out there, and Blue Origin is up and coming. And I wanted to get back into the space industry, or get into it. And via the mechanism that was my newfound skill set and thing I love doing and solving problems with, I was able to get my foot in the door and basically in a way that I feel like I could make a difference and push the boundaries and further space exploration with the projects that I'm doing.
That's awesome. Okay, so we're gonna kind of shift gears a little bit and really look at, you guys are all into the space industry in different aspects, whether it's on the NASA side looking and doing research, or it's on the commercial side developing systems for space. What do you think is, let's say we had a crystal ball and you could look into it and see what the future is. what is the future? What do you think is the future of a sustained human presence on first the moon and then Mars? Let's like think about one of the cool and one of the most interesting things about the space industry is, like you said, it's like it's the last frontier, right? Which is what's that, Star Trek, I think. And so it has this alluring kind of aspect to it because it's something that we have yet to accomplish, or we've only really scratched the surface of it. And sustained human presence on the moon, well, first off, returning to have crewed missions on the moon is the next big step, and then a sustained presence. What do you think is the timeline for sustained presence on the moon? And we'll, again, boomerang, so Colton, then Zach, and then Khalil, yeah.
Cool. Yeah, so this is, I guess, almost the exact thing I'm working on now, so I can't necessarily my timeline for that. But it's definitely soon. And I mean, there's a lot of technologies that still have to get fleshed out and developed and really gained confidence in. But if that can happen, you know, with little hitches here and there, but nothing too significant, then within the next 10 years, I think it's totally possible.
Wow, 10 years. Yeah, that's cool. All right, Zach, give us your estimation.
Well, one of the projects that I'm currently involved in at JPL is called Mars Sample Return, and we're trying to get the first samples back from Mars ever. There are a lot of hurdles to space travel. Not only does it take a long time to get resources to Mars, but even to the moon and being able to space certify something so that you know it's not just going to blow up as soon as it gets there. It takes a really long time. So I think optimistically, probably in the next 20 to 30 years is when we're looking at humans permanently on the moon or Mars.
Okay, so that's the moon. What about Mars? Like, you know probably more about Mars probably than anybody on the panel because you're working on the Mars Sample Return mission. Give us the timeline, what you think, first off, to return samples, and I'm sure that NASA's made that publicly available, what their goal is, and then what is, let's say, the first human presence on Mars.
Yeah, the original goal for Mars Sample Return was to get the samples back in late 2030s, and we're actually entering kind of like another space race, but it's not very publicized right now. China is planning on launching their own Mars Sample Return mission here by the end of the decade, and they're looking to get the samples back in 2030. And the US optimistic goal is to get it, you know, in the next decade. So really, we're trying to drive forward the kind of initial exploration that the US had back in the 60s of we want to be at the forefront of science. We want to make sure that we're developing technologies that can not only help people here on Earth, but in space and, you know, figure out ways that we can live up there. I think the hard part as well is we need to evaluate how we could actually live on Mars because we're not sure what caused Mars to actually lose its magnetic field. If we send humans up there, is there going to be some sort of radiation event that can cause humans to not sustain up there? So there's a lot of unknowns in my opinion right now.
I'm glad you brought up the space race that's currently happening that's really not being talked about. Well, I think there's actually two. There's an international space race between, let's say, us and China. But I think there's also a commercial space race within the U.S. between SpaceX and Blue Origin. And so I want to ask anybody to comment on that. But if you guys have watched, so if you're not like paying attention to these two companies, there's a lot that, I mean, there was just two landings. There was a landing on the moon by a commercial lander company just a week or so ago. The Blue Ghost landed. I think Intuitive Machines just landed another lander on. And Blue Origin launched their New Glenn rocket just a few weeks ago. And SpaceX is launching, you know, Starships all the time. And what's interesting, if you look at this is, you know, my view of the two companies, they have two approaches to how they're innovating, let's say. SpaceX does a lot of tests and rapid, you know, iterations, and the Starship crashes in the middle of the ocean or blows up on reentry, like Kyle was talking about. New Glenn, Blue Origin did a lot of prep in order to make sure that New Glenn worked the very first time, and it did work the very first time, which was phenomenal to see. And if you didn't watch the New Glenn launch, you should go, because it was actually, or go watch it on YouTube. It was really cool to see. I stayed up. I launched at like 1 a.m. in the morning. I was like randomly up, working on my PhD probably. And then I was like, oh, hey, New Glenn's launching. And I watched it. It was really cool to see. So, but for all of you, if you haven't tuned into what's happening in the U.S. space race, those two companies are actually pushing each other, I think, to maybe the benefit of our country being able to, let's say, advance in the space industry. I think we'll hopefully see that timeline reduce to go back and pick up the Mars sample. Question is, are they going to pick up our samples, or do they have their own samples up there that they're picking up? Is it a race to just pick up the samples?
They actually have their own samples that they've already done up there.
Oh, okay. Yeah. Wow. Yeah. So very interesting. Okay, Kyle, you're next. Give us your estimate of what you think is a reasonable timeline for sustained human presence on the moon, and then we won't say sustained presence on Mars because that, who knows, that's pretty far out. But let's say the first crewed mission to Mars.
Interesting, yeah. I'm pretty much riding the theme that you guys are saying. I think it's really difficult to tell. Like Zach was saying, like Colton was saying, there's a lot of stuff that still has to get sorted out. Like Zach was saying, I think people say space is hard, and that's like definitely not an oversimplification, but I would say it definitely is going to come down to like, well, a lot of willpower in terms of getting stuff up and going, and also a lot of collaboration. Like a lot of the domestic companies, space companies that are doing these launches and testing these things, they're actually doing them to like partner with NASA. So for like Artemis 2, 3, like those rockets for those are supposed to be like HLS systems that aren't necessarily like explicitly and solely like NASA built and everything. Like there are plans to have those be some kind of like Starship variant or whatever. So a lot of the developments that are being made in the commercial world are, like Tyler was saying, just kind of coming together to kind of collectively get the country to space and beyond, wherever the goals are. So it's kind of difficult to tell because it's like if you rely on like one kind of peg, I guess, then it could definitely take decades. But if you're, I guess, kind of betting on everybody and stuff like that, I think something could culminate pretty well to get to the moon within the decade and stuff like that. To Mars, there are so many other like questions that just haven't even been thought of yet. So I think it's obviously, I don't want to say easy, but it's one thing to get there and just kind of like crash into the surface or whatever. It's another thing to completely understand like the environment, the magnetic field, stuff like that, and actually have sustained presence. I would say it'll probably still happen within my lifetime, but to pinpoint it is really difficult for sure. And that's assuming like nothing super crazy happens on Earth during that time. So,
Which may or may not speed up or slow down the process, is what you're saying.
Yeah, I'm gonna keep it pretty like safe.
Yeah, you're going further out. You're safe. You both mentioned that you keep using this word, the decade, and I think that in the back, like there's a famous quote by JFK in the 1960s where he said, "We're going to go to space, we're going to go to the moon by the end of this decade," right? And he said, not because it's easy, but because it's hard. So that word, the decade, like by the end of the decade, that you guys are both saying that, and I think then in the way the industry remembers that, right, from the 1960s, that's what the U.S. did in the 1960s was they set that goal, which was at the time absolutely insane. And I started off this morning with a presentation, and I brought up, I think I've mentioned it, I'm sure you guys have heard me say this before, but the average age in NASA mission control in 1969 was 28 years old, right? And I always use that as an example because that is an extremely young age, right? And we kind of think of, oh, this is something that, you need to be very advanced in your career. It's like the average age of you guys is probably, well, it's not 28 years old. You guys are all younger than 28. But you've had me in there. Now we're probably an average of 28. So, so there was a lot of people in NASA at the time who were just right out of college, maybe, probably in college as well, in their degree programs and whatever. And so there's the opportunity to get engaged in the space programs, even at these early ages that you guys have demonstrated. All right, Leanne, let's hear your estimation on what you think the return to the moon, sustained human presence, and then Mars.
So I'm kind of like Kyle. Like I can't. Like I'm gonna be honest. I'm not someone. If you're gonna ask me for a number, I can't give a number right away. But my thought process, what I will say is, living in Los Angeles, living in basically around the corner from El Segundo, which is quoted like aviation corridor. Most or like defense, but there's a lot of startups in Los Angeles specifically for space. Some of the bigger ones that are starting to come up now, like the last few years, is like Astrolab. If anybody's heard of Astrolab, they're making their own. I think with NASA's funding and their support, they're trying to make their own rover, Flex rover, for the moon, and I think for Mars. And there's a lot of companies like Astrolab out here that they have all this money literally put into making a rover that's going to fit moon's conditions, Mars conditions, stuff like that. And then you also have companies like Vast Aerospace, which is becoming bigger and bigger out here. They're in Long Beach, and their focus is creating space stations that we can like actually dock on. Just normal people could dock on. It's not going to be like the ISS. And then like my first internship actually was right after I graduated from Luminosity and from ASU. And I had the privilege of kind of just seeing some of the inner workings of what they were doing for the Deep Optical Space Communications Program. And that kind of correlates to the Psyche mission a little bit. And there was a ton of funding, a ton of push to get all these small companies to come together and contribute to like a bigger project related to space travel, to specifically the moon. And I firmly do believe that, like, especially with our current, like, I would say funding and the amount of support now that we have for space, that it's definitely plausible. And I think it's not that it's plausible, but I think it's actually doable in a quicker amount of time than we've ever seen before. I think a lot of like our ability to actually go up into space and the push for us to actually get to that point where we're on the moon and we're living on the moon and we're living on Mars is a little bit like moral. Like the more you have like especially a government that supports like these space programs, and the more you have, you know, people like Elon Musk or small companies coming together and being like, yeah, we got to get to the moon, we can get there. Like the more confidence you kind of see with people about going to the moon or going to the Mars, you'll definitely notice that there's an increase in amount of work that gets done for those missions to get accomplished. So I don't know if that really makes any sense, but I guess my point is what I see right now, especially living where I live, there is a huge like push and there's a huge motivation and there's all this excitement to get to moon, to get to Mars, way more than we've ever seen it, especially with Space Force now. Kind of like our government influence, I think, for all that right now is Space Force. So I'm pretty hopeful it could happen pretty soon, maybe under 100 years. But an exact number, I could not tell you that because I also know firsthand, anytime you create anything for space, you're never on schedule. Like I've never met a single company that's actually on time creating their flight, like tech, their flight satellite, whatever. But you know, with the proper support, like usually projects like that get pushed really quickly. So. Yeah. Is your mic on?
Can you hear me? Mic's on.
Yeah, we can hear you.
Oh, we
okay.
can hear you.
Okay. So what I was saying was that's good to hear kind of the kind of your fingers on the pulse of this commercial space industry being in that part of LA. And that actually leads into the next like and final question actually perfectly because, you know, what I want to, you know, the next question that I want you to answer is how do students, so we have, you know, a bunch of students here from Luminosity, and some of them, you know, maybe wanted to get into the space industry from an early age. Some of them don't even know, but maybe will eventually be in the space industry. And I think we've seen similar things in our current NASA projects. But how would, and you mentioned a number of startups that are in the space industry in the LA area. How do students, let's say current students in the lab in ASU, get into the space industry? What do you recommend? Give us your recommendations. We'll start with Leanne and we'll go back through everybody and it'll be our final question today.
Okay, this kind of follows like what I answered for the first question. So even though I wasn't necessarily like looking for like a job in a specific field, what I will say has been working well, not just for me, but for a lot of other engineers I know, and a lot of people who I now know in industry, is if you get an opportunity, especially as a new engineer, I think most companies like are a little hesitant. Like you guys probably get that feeling. Like I got that feeling when I first applied to my internship. There was like hesitation because, I'm fresh out of school. I might not actually be that knowledgeable. I don't have experience actually building that many things. Um, the big thing for me is if you get an opportunity to interview, take it serious. If you get an opportunity to work, um, like a job, maybe it's not in your field, but it's with, the skill set you have, or maybe it's not even with the skill set that you have. Just take it. I think a lot of the reason I'm here where I am now is because I'm not much of a person to say no to opportunity. And I think Tyler knows that as well. I used to overload myself quite a bit. Um, when you get an opportunity, just take it because you'd be surprised like how interconnected like the world really is. That sounds so deep, but a lot of my jobs like I've found or like I've been able to network with other companies because someone I knew at my current job like has a cousin or they have an aunt or they have an uncle or like in my case, like I was at USC for my graduate program. I was at a career fair and I actually walked up to somebody who used to work at Raytheon. And they're like, "Oh, hey, my boss needs a replacement." Like that's how I got my job at Raytheon. Um, so I firmly believe in if you have an opportunity, just take it. If it's any sort of relationship to like what you want to do, just take it. Build the experience, and then you'd be surprised from there how quickly a lot of these industries will want to acquire you. LinkedIn has been my best friend for finding new career opportunities as well. And a lot of these startups in Los Angeles, they go on LinkedIn and they'll stalk your LinkedIn. They stalk like what kind of projects you do. And what I will say for sure, on my LinkedIn, I put a lot of the projects I did for Luminosity and I put them on my resume. And all these startups out here like love, and they always ask about Luminosity on my resume. Like I'm not even joking when I say that. So I think for me, just take opportunities where you see them, because you just don't know where they'll lead. So.
That's great, thanks. I think there's kind of like one of the main things that you kind of touched on was the importance of networking, and that's something I'm always trying to tell the students. I'm like, you like get out there, talk to people, go to the career fair, talk to like anybody you can talk to in these industries is super valuable. Whether they'll give you feedback about your resume or they'll just introduce you to somebody. You guys all have phenomenal resumes. The projects you do here are super applicable in industry. And so it's often finding the right person, finding somebody inside of these companies. And so that's great advice.
Yeah. If it's any consolation, I went to a coffee shop this past Sunday and I was just reading a book. And I was at a coffee shop right around the corner from this like aviation corridor. And this couple sat down next to me with their newborn baby. They're like, "Can we sit with you? There's no other place to sit." And I was like, "Yeah, for sure, of course." And sure enough, the guy has his own startup. He's doing defense space tech. And he was like, "Oh my gosh, I could use your help doing this. Like, we should talk again." Like, that's what I mean by opportunities. Not just the ones you get like formally, but like you will pick up conversations when you're around the right group. So.
A great story. We found a number of students at Luminosity in similar ways. We just ran into them in coffee shops and other places. And so take advantage of the opportunities you guys are given, or you find, or you make, or whatever you kind of, get out there and meet people. Kylel, your thoughts. How do students get engaged? What do you think? What's some tips?
Yeah, I would say definitely echoing like a lot of what Leanne was saying. I got my position straight from like somebody who knew somebody, and you just keep kind of climbing that. And I would say stuff that is like oftentimes serendipitous, not necessarily like singular, like they will happen in life, period, but it's always kind of just like right place, right time type of deal, and always kind of be open to opportunities. But I would say stuff that you can work on as an individual is just always like kind of um I'm trying to progress and trying to like be better at the stuff that you're interested in. I think like everybody on the panel I had a chance to work with, including Tyler at Luminosity, and like the amount of like late hours and just like really getting the stuff done, like it's unparalleled. Like I don't even do that for work. Like nowadays for work I'm like there's absolutely no way I'm doing this for free anymore. So I would say like if you have a passion for like anything, it doesn't even have to be STEM. Like at NASA a lot of people internally people say like, yeah, NASA's like more than just like STEM and engineering, like they're administrative, there's like all this other stuff. You just have to like really find your passion and stuff, and don't be afraid to exercise and stuff. Don't be afraid to fail, especially if you are STEM, because everything that was ever written down in a science or math book was found from like 100 ways of doing it wrong. So you really have to, you kind of have to fail to actually succeed as an engineer. So definitely don't be afraid to do that. Explore things on your own time, like really just kind of get your craft together. Like this is the safest space you'll have to do that right now. After school, it's kind of like everything costs like either money or time or whatever. But right now you have like the really safe space, especially if you're at Luminosity, to just grow and really grow and definitely take advantage of that, all the opportunities that come to you guys and stuff for the next few years, because they can launch you for sure if you let them. So
Awesome. Thanks, Kylo. Zach, your thoughts?
Yeah.
You're kind of in the middle of it right now, so you can walk us through some of that too.
Yeah. So my one piece of advice would be to take advantage of any opportunities that come across. Everything from talking to a recruiter to just attending socials. Last year, when I was actually out at JPL in person, there were a lot of random events that would come across, like the aerospace games, where a bunch of aerospace companies out in LA and across the country come together to just play like volleyball and beach games, which was a lot of fun. And that's a great opportunity as well to meet other people from careers and see, what are the other available opportunities for me that I could take advantage of. I guess another example would be last year, Ellie, who works in the lab, well, I guess used to work in the lab now, she had an internship at Honeybee Robotics, and they were hosting their own version of like a beach day, and so I tagged along, and I met Grayson, who was also formerly in the lab, so you never know kind of who you're going to run across and provide you opportunities to network and connect with them. There's also kind of imposter syndrome that I'm sure we've always felt at some point, where you feel like you're not good enough in the current role, you're comparing yourself to other people. My piece of advice for that would be understand that you are where you are because of what you've accomplished so far, and don't allow that to prevent you from taking advantage of opportunities.
That's great. Yeah, I mean, I think that's 100% accurate. I know everyone feels that imposter syndrome, and it's natural. And I also think the type of people that all you guys are, that's, you naturally think that way. But and when I see, each of your resumes, I'm usually like, you need to talk more about yourself and how great you are, which I'll say some words about this group here in the panel when we get to after the last question here to Colton. But Colton, walk us through what you think for students, how they get engaged in the space industry. Give us some ideas.
Yeah, so my biggest thing, and I guess this isn't necessarily the space industry or any industry that you're interested in, is kind of three things. One, being passionate. Two, having perseverance. And three, staying humble. And those three things together, it's kind of like a three-body problem. You don't kind of know which one's pulling on which, but they kind of work cohesively together. And if you keep those things in mind when going through your career, it can get you to any place that you want. So being passionate, obviously, like if you love doing something, it's not going to feel like work. It'll come naturally. And it will kind of keys into the next one of perseverance. When things get difficult, you can lean on that passion to really push yourself through any problems you're facing, or to push yourself beyond the capabilities that you have, which goes into being humble. You don't know everything, you think you know everything, and as soon as you start to corner yourself into thinking that you're an expert, that's when you start to lose your credibility or make assumptions that could lead to failures. And being an engineer, that's really important, is to never assume and to make sure you know the facts, and being humble and being okay with saying, I don't know, and then having the perseverance to figure it out.
That was great. Honestly, that was the perfect summary to the space panel. I appreciate all of you joining. Like I mentioned, each one of our panelists today was a Luminosity member. It's interesting, actually, 3 of you were from the Polytechnic campus, so it was nice to have a bit of a reunion there on the Polytechnic team. And each of you have done amazing things. I'm super proud of all of you and what you've done and accomplished. This is one of my favorite things to do. This time of year is one of my favorite times of year to help students get jobs and internships, because it's about this time of year that you're coming to us and staff saying, hey, I'm looking for an internship or a job. I don't know what I'm going to do. I don't have a job yet. And then it's like a week or so later, you're like, I got this job. It's amazing. I think Nick is actually, Nick's around here somewhere. He's just got a job at Blue Origin for this summer, so he's going to be up there. We've got a lot of other students who have been, getting their internships locked in and their jobs, and this is really what it's all about, is really helping you build your skill sets, getting you experience on these types of projects, and then just seeing you launch your career. I mean, this is really just the start of it. So I really appreciate you guys joining today. I love the space industry. I'm excited to see where it goes. Everybody who's not involved in it should kind of keep an eye on it, and who knows, you might end up in it at some point, like some of you have. And with that, we'll just wrap up today and be back here tomorrow. We'll actually do one more thing before we wrap up, but I want to have Jasmine and Rob and Stacy up to the panel, up to the front. So why don't you guys come on up here, and we'll just kind of conclude the day, because I think that's it, right? We don't have, a brief photo? Okay. Before we do that, though, so you guys can come on up. So this has been, like we've talked about, a lot of things going on, lots of new projects, and the team, this is our staff, have done an absolutely phenomenal job. And just I think it was just a few weeks ago, each member of the team received a promotion, much for their dedication and hard work. And we didn't announce it, at the time. I think it was on LinkedIn and stuff like that. But I wanted to just formally announce it, and for all of us to congratulate them individually for their contribution, for their dedication, for the nights, the weekends, the late nights, the early mornings, all the work that goes into this. And so let's start with Jasmine. So Jasmine was recently received a promotion of assistant director at the Luminosity Lab, and yeah, you guys can clap for that, because that is huge. So she has done an outstanding, phenomenal job. She was a student in Luminosity, and was unbelievable, and then joined our staff and has done a phenomenal job. She's engaged with a lot of you guys this year in a lot of different ways, and has been absolutely amazing at the job, and deserves that recognition for her work. I was in my defense today afterward. One of my committee members, who's a professor in the engineering department, he was like, oh, because at the end I acknowledged the Luminosity staff, and I mentioned each one of you. He's like, I didn't know Jasmine worked for you guys. I was like, yeah, how did you know Jasmine? It was Pat Phelan. And so, yeah, he was like, she was, I think you worked with him in your high school, and then when you were here at ASU. And so I was like, we were so lucky to have Jasmine. She's amazing. And so anyway, that was actually super funny that he brought that up. So congratulations to Jasmine for her promotion. Stacy has been with the lab the longest of any of us, from probably at the end of 2016, or the beginning of 2017, has been seen the lab go from probably the original 15 students that were in the lab, and she knows all of them, and she goes out to coffee with them when they're in town, to what you guys hear today, and has seen these students just go from the very early days of the lab through now, and has been an absolute phenomenal influence on all of our students. Has, I think, impacted every single one of their lives in a way that probably none of them even currently realize, will probably realize at some point, if they don't currently realize it. And she received a promotion as the senior research director senior research manager of the Luminosity Lab, and that is just an absolute phenomenal recognition of her contribution. So there's no way we could do any of this without Stacy. All of you know that, because I know all of you guys engage with, and Stacy makes everything work behind the scenes. Rob was recently just promoted to the position of director in the lab, and he's been here since when he and I joined at the same time in Luminosity and has been, since, from those early days of, I think, 2018, seeing the lab grow, expand, kind of that explosion of projects and students and things, engagement and things like that. And he's led the lab in a lot of different ways and engaged with the community and our different community partners. And he's doing all kinds of things behind the scenes that you guys aren't seeing day to day, and then has been there supporting all of you. And so he received that promotion as director, and which is, much deserved. So congratulations, Rob. So with that, I think I'd like to just conclude the day. We'll get everybody up here for a photo. And so yeah, we'll have Derek take the photo. We'll get everyone up here. Everyone did a great job wearing their polos. I'm impressed. Yeah, except for Rob. Yeah, spoke too soon. But thanks, everyone. So come on up here. Kyle, Leanne, great to see you guys. I don't know if you can see me, but I miss you. So come back and see us, please. Yeah, you can stay for the photo. You should stay. Stay up there. We need you.
I'll come back this summer.
Yes. Oh, that's a terrible time to come back. Don't
No,
come back this summer. But if you do come
fall.
back, come see us. So, all right, everyone come on up here.
Come on up. Yeah, on the stage. Not in front of the stage.
The polos is nice. I wonder where Kyle's and ours
You
are.
gotta come up here. Yeah. Colin was like, now you work at Blue Origin. I was like, why are you up here? He said you had to work.
Let us know when you guys are taking the picture so we don't blink or anything. There's a delay.
Yeah. It's so quiet.
It is. I don't know what the mic's on. I don't know if they can hear us.
Can they?
I don't think so.
You can hear me clap once.
I don't think they can hear us. Okay, I think it's time to smile. No idea when it's time to smile.
Just stand here.
Yeah. Are there like live captions going on or something on the screen? There
That's
are.
so cool.
That's
Oh, so they
pretty
can
cool.
hear us. They can
Well, they
read
can at
us.
least read us. Yeah.
This is so cool.
Yeah, it is. It's
The
crazy.
lab is so big.
It is. When we were graduating, it was like so small. Okay.
We gotta do the forks up.
Oh, I
Right
think
on.
they dispersed quick. I don't think we're yeah. Okay. I'm not completely sure what's going on next,
I don't know.
but
Yeah, do we just stay here? We can stay here.
Okay,
We'll just smile and wave.
exactly.
Whoever waves back.
Oh, there's announcements.